Hello there, and hi everyone. Welcome to PlayStation Portable Homebrew Developer Conference 2026. We have yet again another awesome year, and we have a bunch of presentations lined up. The starting sequence of the presentation order is going to first be with Steel Blossom PSP by Elest Alive. Give us just a moment to get that set up and have his live presentation go on.
I am ready, yes. All right. Sounds good. All right, so today I'm going to be talking about my game, Steel Blossom PSP. We're going to go over how the game was made, what I plan on doing for it in the future, any issues I encountered. So let's get started. All right, so I'm going to show you a trailer that I made. This is a fast-paced hack and slash game for the PSP, written in C++ and SDL2, and using the PSP SDK, of course. It's a wave-based game, so these are all different waves. They all have different enemies. I'm just showing off here a few of them. These guys summon stuff. There's one of the bosses. So yeah, that's basically it. Here, I'll skip to. This is another boss right here. All right, so getting into it, let's see. So first I want to talk about why I actually chose SDL2 specifically. And the reason for that is actually when I started making this game about a year ago, I was writing it like with just like GU code straight up. And I realized that would take literal years to get a game like this out. So I just looked at what other options there were and stumbled upon SDL2. Of course, right when I switched to SDL2, I noticed that it was just much easier. I was able to iterate much quicker, add new features, debugging was easier. It was just a much easier process overall. And the reason why I didn't choose SDL3, because I know that was available at the time, it was just relatively new at this point. So I just didn't, I wanted to stick with something that's sort of been around for longer and proven itself, I guess, in a way. But I did encounter some issues with SDL2. Not many, but there's just like inherent overhead using something like this just because you don't have all the fine control that you would normally. The only real issue that I had was with the SDL2 TTF, which I'm pretty sure is fixed now because I remember seeing a GitHub issue about that specifically. But it would basically just crash on my PSP every single time. So instead of trying to use fonts, I just made them into images and rendered the images. That was much better. For me personally, I think it was just harder because I was pretty new to PSP in general or making games for the PSP. So it was harder for me to learn about everything that's sort of happening in the background while using SDL2. So I just had to kind of do research on my own for that. Now, talking about some of the memory issues and CPU speed that I ran into, I actually didn't run into any issues at all until the last month or so of development. So when I first started making this game, by default, I was just like compressing all of the sprite assets. So the player and the enemies are all compressed down to 16-bit color. The only asset that is not compressed is the background image. The only reason why I didn't compress it is because I didn't really need to, but I could. So as I began adding more assets and eventually music, I actually started to run out of memory and I encountered some pretty insane stuttering. The game was basically completely unplayable. So to fix that, I downsampled all of the sound effects to 22 kilohertz mono from 44 kilohertz stereo. That already helped a ton. But for the stuttering specifically, I had to downsample the background music as well to 22 kilohertz mono. And yeah, that basically just solved all the stuttering issues, or most of the stuttering issues. And it freed a ton of memory, but it still wasn't really enough. I could have compressed more aggressively, of course. Like, for example, the alpha channel for most of my textures, I just don't even need it. So I could just get rid of that, save some more memory. But yeah, it wasn't necessary. And just using these, there was not much quality loss. So I think it was pretty good. But to save on more memory, I really just had to reorder things. So I had to pay attention to where I was loading and freeing all of these assets. So I started to preload all of the persistent assets. So all the enemies that will show up in almost every round, they will be preloaded, and they, of course, freed when you close the game. And I started to also preload the, no, not preload. I was loading the win, death, and wave cards on demand, and then I freed those immediately when I'm done using them. So beforehand, I was actually preloading the win, death, and wave cards as well, like in the beginning of the game. And this reserved like a few megabytes of memory, and that was just too much. Along with everything else, it was just too much, especially for the bosses. Since some of them, like one of them that you'll see later, spans 3 separate sprite sheets, so it was just like way too much. To fix that, we just load them on demand. That, of course, uses less memory in the moment. And altogether, this saved about 6 megabytes. That's like a rough estimate. And of course, it significantly reduced stuttering. So now I'd like to go into some issues that I got into with animations. This is not PSP specific, really. This is just like animation issues, because I didn't make these sprites. They were made by a guy named Pen USB Mike on Itch. He's really good. But I had some issues with his animations. So first, I want to show you actually an issue that I ran into. So this is what this enemy looked like before. It's kind of hard to see, but you can see when she jumps up like that, it's sort of a teleport up. There's no smooth transition like there is when she comes down. So of course, I wanted to have a smooth ascent up. And to fix that, as you can see here, that animation is called the air attack. So right when we jump into this air attack animation, we calculate the difference between where the first frame of that animation wants to be and then where our last rendered Y position was. And that difference is how far we need to move to get to that desired position. So to actually apply this down here in the render calc function, this is called every frame. We apply the offset to the destination. So this is basically what tells us where on the screen that should be rendered. We apply this so that instead of rendering the first frame of that animation at the top where it wants to be, we render it basically at the last rendered Y. So we render it down here. And then every frame we shrink this offset until it gets to 0, which basically creates this little, we slowly let it go up to that desired position. And I can show you what that looks like now as well. It's a subtle change, but I think it looks much better. It's much smoother. You can easily tell when the attack's coming, and it also lines up better with the sound effects that I added on later. One more issue that I had, this one's a little bit more obvious. It was with the Blood King. I can show you as well. This one's very obvious, actually. You can see he's like shaking all over the place. I don't know what caused this, but in the actual frames themselves, they were just like drawn side to side. I'm not entirely sure why. But to fix this, basically we have in the code, you'll see we have these anchors, anchor X. I'll just focus on that one. It's basically just a common point between animations so that they all line up perfectly or nicely. And the reason we have different anchors for different animations because they're not all on the same sized canvas. But the reason why I couldn't use just a new anchor for this animation specifically was because you saw it shaking at these like different positions. So one static anchor would just like not work. So what we do instead is we check how far from that position we move each frame. So as you can see, for the first 4 frames, we're not moving at all. But then on the 5th frame, we move 20 units from that point, and then 3 units and all that. So to correct the anchor, we basically just return whatever offset is correct for that frame, and then we apply it to that static anchor, which gives us a more dynamic anchor, if you will. And then we do the rest of the rendering calculations, and I can show you what it looks like after. This one's much more obvious. You can see he stands still right there. It looks much better. You might notice that it's still shaking just a little bit, and that's just because these values are approximations, really. They were all like calculated by hand, but they're close enough in game you don't really notice it. So now for the roadmap, I'm allocating, I guess, the next month of my time because I'll be moving soon, so I don't have too much time, especially with doing all the preparations. But I will be focusing the next month on bug fixes, of course. If anyone encounters any issues, just let me know, DM me, or make an issue on GitHub, more preferably. I also want to optimize a bit more. There's still some stuttering when you're playing the game. It's not perfectly smooth, and I want to see maybe it's still the music that's causing that. So I want to look into that. And then I also want to try to avoid IO reads between waves. So as you saw before, we started loading the wave cards on demand. And that, of course, causes us to load in an asset between waves, which causes a slight stutter. And that's pretty annoying. So I want to see if I can somehow avoid that. Oop, sorry. All right. Yeah, that's basically it. So thank you to everyone who's listening, and thank you to everyone who's downloaded the game. If you haven't already, here's the itch, here's the GitHub, whichever one you'd prefer. And yeah, let me know what you think.
Yeah, that sounds great. Right now, we'll also be looking for questions from the audience if you have the time to answer them.
Sure, yeah, no problem.
I suppose we'll see any messages in either the Discord chat or from the PSP live stream.
Check the live stream. Subaru mentioned, yes, peak.
Why is everyone talking about LARP in the live stream? I don't know either, dude. You're getting some
LARP?
apparently. There was a user who was spamming and got timed out.
No way.
Yeah, and then so yeah, you just have some compliments. Great job, loving the Boston animations.
Oh, yeah.
Oh, here's the first question.
Thank you.
Are you targeting 32 megabytes or 64 megabytes for your memory problems?
32 megabytes. I wanted this to run on the PSP 1000. I have a 2000 also, but I don't want to mod it. So I only have a modded PSP 1000. So by default, I'll just targeting 32.
Yeah, that
Oh
sounds.
yeah. If you guys love the boss and the animations, guys, check out that guy, Pen USB mic on itch. He's the one who made all the assets. He's very talented.
Yeah, that sounds great. I think that's it for questions. Of course, feel free to stay in the chat, and oh, there might be one in the live stream chat. Discord live stream channels are interesting.
Oh, which one is it?
Okay, never mind. That's not the. Yep, that's not the issue. Anyways, okay. Well, thank you for presenting, and we'll go on to the next presentations. They're pre-recorded, and thank you so much, Alest Live, for giving a presentation.
Of course. Thank you for having me.
Good day.
So for our next presentation, we're going to have GameMaker Re-Engineered by Sergo Devs, which will be our first pre-recorded presentation. Without further ado,
Good day everyone, my name is Sergo, and I'm known online as Sergo Devs. It's no secret to anyone that thanks to my port runner butterscotch, you can now play the real Undertale on your PSP. But I got too caught up in this topic and I decided to go much further. And that's what today's talk is about. GameMaker Runner, a GameMaker script bytecode transpiler, and a resource converter. GM Re-Engineered is a 3-in-1 package. It is shared in a new era of GameMaker-based game development and porting. Initially, it was a port of the infamous Butterscotch Runner, capable of playing any GameMaker Studio or GameMaker games exported to a virtual machine built of your game. Unfortunately, Butterscotch was not perfect and optimized for the PSP. It was cross-platform, used 90% AI-generated code, and didn't take advantage of the hardware features of the platform it was compiled for. Fortunately, I decided to fix all the issues and improve the runner's performance. I wrote 95% of the Butterscotch source code and added a large number of built-in GameMaker functions. I also utilized the PSP's technical features, which reduced CPU load and RAM consumptions. Unfortunately, this wasn't enough for excellent performance in large games like Deltarune. You see, any interpretation on the PSP is very resource intensive, and the PSP processor was originally designed to execute MIPS instructions directly without heavy interpretation. And I've got an idea. If we don't interpret the GameMaker language bytecode, but instead translate it into C code and tie it to the runner before compiling the runner itself, we will eliminate 99% of the interpretation, and it worked, of course. This greatly increased productivity, but manually translating bytecode into C scripts for each game is a very large routine task. Therefore, I created GM Re-Engineered Transpiler, a smart utility that allows you to analyze the entire bytecode of a game, understand where it is beneficial to inline the code, reduce the number of functions calls but increase the code size, where to apply optimizations, even at the level of translating bytecode into C functions, and correctly tie them to the runner. The main advantage over ChoviGM and its old Karoshi game runner is its low RAM consumptions, thanks to resource streaming instead of loading textures, sounds, and music at startup. Thanks to this, GM Re-Engineered can run games like Undertale, Deltarune, Nuclear Throne, and other major indie titles on the PSP. Importantly, I've solved 3 major problems with the Karoshi Runner. First, now you can use modern GameMaker engine to develop your games, significantly increasing your development capabilities. Secondly, thanks to the transpiler, your scripts compile natively, giving you native performance on the PSP, where the Karoshi Runner runs at 5 FPS, GM Re-Engineered runs at 60. And the last, thanks to the separate texture atlases and sound banks, you get significantly more free RAM. Let's talk about some technical features. Textures now use CLUD4, CLUD8 format instead of the full RGBA format, significantly reducing RAM consumption. A single atlas now takes up 128 or 256 kilobytes of RAM instead of 1024 kilobytes. Textures are cached in RAM for quick access and are also loaded on the fly during use, which helps maintain RAM consumption even in graphically intensive scenes. Interpretation now uses processor registers and scratchpad RAM, significantly speeding up script interpretation. Furthermore, data movement speed has increased thanks to the intelligent use of DMAC. VFPU helps speed up some mathematical calculations with matrices, vectors, and some trigonometric functions. For example, the game Undertale uses a large number of sync calculations calls per frame. Music and sounds are now decoded and mixed in hardware using the Media Engine, a MIPS multimedia processor. The same thing is applied to video. MP4 videos are decoded by hardware, allowing the processor to interpret scripts. This tool will be publicly released on 1st September, and I'm currently actively refining the toolkit to perfection. I really hope for your support. And PsychoDevs was with you. Ask your questions right now, because even though this is a recording, I'm already here and ready to answer any questions regarding GameMaker Re-Engineered.
That was an awesome presentation by Devs, and next up is Devs once again with Ren'Py Re-Engineered.
Good.
And without further ado, oh shit, here we go again.
Good day everyone, and now I'll take up 5 minutes of your time again to announce another project that's in an active development. My main dream was always to take a PSP on a trip, because the PSP is incredibly convenient for reading visual novels. But here's the problem: there aren't that many visual novels for the PSP, and the number of well-known titles can be counted on the fingers of one hand. And this is where the porting of the most well-known visual novel engine for the PSP comes into play. After all, by porting the engine itself, we'll be able to run games such as Doki Doki Literature Club, Everlasting Summer, Katawa Shoujo, and hundreds of other awesome games. Everything's right, we're talking about an engine called Ren'Py, and the project is called Ren'Py Re-Engineered. But this project is much larger than the previous Ren'PGE, Ren'Lua, Ren'PSP, and other Ren'Py clones for the PSP. Let's start by looking at what distinguishes this latest Ren'Py clone from previous attempts to port the engine. I'll start by saying that Ren'Py Re-Engineered is planned to be a full Ren'Py engine capable of running every single visual novel ever created with Ren'Py. And no more Lua, we're serious about this. Let's start with the fact that Ren'Py Re-Engineered is a complete re-implementation of all parsers for all Ren'Py languages. Yes, that's right, Ren'Py is that engine that handles the interpretations of several syntactically interrelated languages at once. The first is the core Ren'Py script language. In Ren'Py Re-Engineered, its parser was rewritten in C to optimize parsing speed and provide full memory control. After all, we're working with a PSP that has only 16 kilobytes of scratchpad RAM and 32 megabytes of RAM. The Ren'Py script language parser uses the standard node system and prepares the execution of nodes and the chains of nodes that are being built. Next in line are two similar but distinct languages, Ren'Py Screen Language 1 and Ren'Py Screen Language 2. And don't let the number fool you, these languages versions are fundamentally different. Of course, Ren'Py Re-Engineered parses those two languages using an exact algorithm rewritten in C. Finally, no less important is the Ren'Py UI language. It's more of a supporting syntactically simple language, but thanks to it a large number of menus, tooltips and other windows in a visual novels are built. But, about languages, the very fact that Ren'Py works on the PSP means porting a full-fledged Python 2 or 3 interpreter, since Ren'Py supports dynamic execution of Python code right during the game. And here MicroPython comes to help us. Building a MicroPython interpreter for the PSP was not difficult. The harder part was optimizing it using the hardware features. And here's the 16 kilobytes scratchpad RAM makes itself felt, because nested loops in some novels can be very deeply recursive, and it's very easy to consume those 16 kilobytes of memory. Unfortunately, I did not really want to lose speed, so I decided to keep using the scratchpad RAM when interpreting Python code. Also, most of the novels use standard modulus that come bundled with Python. However, MicroPython was stripped down for performance and compactness, and I had to port most of the standard modulus. I also rewrote some critical Python modulus in C, such as Re and Pickle, because they are very often used in the engine itself for data serialization. For example, the file map and the Ren'Py archive. Of course, resources needed to be converted, since the PSP wasn't designed to display Full HD and sometimes even 4K images on the screen or to play FLAC music with a very high bitrate. This would simply kill performance. Therefore, it was decided to convert the textures and audio into a format that is suitable for PSP, as well as to implement a system for dynamically loading and unloading resources, including caching and predictive loading. I have not really thought about transpiling Ren'Py script since the performance is already high, but the script parsing time really leaves much to be desired for the PSP. This project is still under active development and active testing, so stay tuned for updates on the PSP Homebrew community Discord channel, but the first versions for public testing are expected to be released this year. Well, SegaDevs was with you, and I really hope we'll see each other again soon. Unfortunately, this time there won't be questions and answers sections since the presentation turned out to be quite long for a short announcement.
Thank you, Sergo Devs, for the presentation. And I see that he's in chat, so he'll be answering any messages that you give in the livestream chat and probably also in the Discord as well. The next presentation we have is from Slendy, and it's about PSP dev on Nix. I apologize for the flashbang, but without further ado, let's go.
Hello, I'm pspdev-nix, and today I'll be talking about it. pspdev-nix provides the necessary tools to have reproducible development environments, easy packaging, and various templates to quickly get a project going. Installing the PSP toolchain can be quite difficult. The installation steps can be entirely different based on what operating system you're on, and if you don't have any of the operating systems listed, you have to rely on Docker. Even if you can go without Docker, you still have to manually install dependencies yourself, manually manage environment variables, and deal with binaries that can break after system updates, either leaving you waiting for new binaries or making you compile the whole thing from source yourself. For development, Docker also has some significant limitations, like poor host integration, making things like LSP support incredibly difficult. Needless to say, all of this was quite frustrating for me, so I decided to make the PSP toolchain available through Nix. So, what is Nix? Nix is a functional, reproducible package manager. Okay, I realize this isn't very useful, so let me rephrase that. Basically, you describe your development environment declaratively, and Nix ensures everyone gets the same tools, libraries, and build results. Nix is available in Linux, macOS, and Weasel. One of the benefits of Nix is that packages can always be built from source in a reproducible way. In practice though, most people won't build everything from source because pspdev-nix provides a binary cache that Nix can smartly download pre-built packages from. pspdev-nix is distributed as a Nix flake. For the purposes of this talk, you can think of flakes as little recipes that produce things like packages, development environments, and various utilities. Now let's look at how a PSP project can be created using this. To create a new project, we can use one of the templates provided by the flake. After the hash, we can specify what template we want to use in our project. Let's say CMake. And now we can specify a name, and then we can enter its directory. As you can see, our project is now fully initialized. We can enter its development shell with Nix develop. Now we can build it with PSP CMake. After that, we can run our project with ppsspp. I would have shown this running on real hardware, but sadly my PSP no longer turns on. Okay, let's say we are happy with our work so far and want to package it. If we look at the generated flake.nix file, we can see that it defines a package, so we can build it with Nix build. The output goes into the result directory, which contains our final ibu.ppp file ready to ship. This is cool and all, but how can we use it in CI? Well, because the build is already declared declaratively, this is pretty straightforward. Well, let's take a look at my project. If we look in the GitHub directory and then in workflows, we can see that we use Nix to build out the package just like before. If we click on the Actions tab and then take a look at the latest release, we can see that the build is green and we have our resulting artifact at the bottom. Besides the toolchain, pspdev-nix also packages various libraries in Homebrew. For example, we can build Arc 5, which as you can see, builds successfully. Of course, there's much more than just Arc 5. In the future, I'd like to package more Homebrew software and more libraries. If you are interested in this project, here's a link to the project's GitHub where you can find more details. Pull requests are always welcome and you can always reach out to me via email or via Discord. This presentation will also be uploaded to my YouTube channel, which you can find here, and I'll do my best to respond to comments in both that video and the conference's VOD. Thank you for watching and have a great day.
That was a great presentation by Slendy. It had amazing animations, really high quality, and yeah, it was really great. So I'm not sure if they're going to be in chat, but they'll probably be happy to answer questions into the future. The next presentation is going to be CrossCraft, and it'll be presented by yours truly. Man, I love OBS when it deletes my own input sources. Okay, anyways, hello and welcome. This is my presentation for CrossCraft, which is a project to port Minecraft onto the PSP and a bunch of other platforms as well. So, actually I realized that this agenda is very out of date, so I'm gonna skip it. So what is CrossCraft? CrossCraft is essentially the idea that we want to faithfully port Minecraft to the PSP, and we want to do it version by version. We really want to savor, you know, the good old days of, you know, classic and like alpha, beta, things like that. The actual fun like parts of Minecraft before Microsoft went and you know, did Microsoft things. So CrossCraft is a clean room re-implementation of Minecraft, which is now being rewritten in Zig on top of the custom Ether engine. I presented about the Ether engine in PSP HCC 2024, and yeah, the project used to be in C++, and it had some bad performance, and overall, I just really enjoy programming in Zig, so it's in Zig now. Basically, we're going for all the historic targets while creating a modern implementation. One of the things we're focusing on is really getting accurate, nitty-gritty, close to the details of each version and making it as Minecrafty as possible. So, to start off the talk, let's talk about the low-power targets and how these really affect the development process. One of the things involved in this is how to build an engine suited for the PSP and for other cross-platform targets. And whether or not this makes your code better or worse. So the philosophy that we follow is that we start with the smallest target. What are the least powerful platforms that we have? For this conference and for this talk, we're talking about the PSP, but the 3DS is a similar like level of low power hardware. And then if we add any of the more powerful targets on top of that, like your average PC, or perhaps the Nintendo Switch, and any other more powerful console, every other platform is just going to benefit by doing the right thing at the lowest level for the smallest targets. Basically, if you run really well on low power targets, you'll run pretty well with everything else. So the PSP is in charge of setting the budget for memory, for the CPU, how many CPU cycles we can take, and for the GPU. We also take this into more aspects of the actual development, such as building the UI for the PSP. Controllers and limited screen space are something you would rather figure out first, rather than run into a problem later and have to, handcraft a solution after the fact and bolt it on to your existing architecture. And this just helps let other platforms win. If you can run it on a PSP, it should run on the latest and greatest epic CPUs from AMD and whatever insanely priced NVIDIA graphics card you're running. So, the CrossCraft contract. This was one of the fundamental changes in the project in the recent years and in the rewrite. So the idea is that we will keep the eras all within the same project tree, and we'll share the improvements between these versions. So for faithfulness, right now we're on Classic 0.30. It has single player and multiplayer with the public Classic protocol. We have ecosystem compatibility using Classic World, which allows our world saves to broadly participate in the existing Minecraft Classic ecosystem. And obviously unmatched portability. We have 7 targets and counting, and it's just going to keep getting bigger than this. So one of the core ideas here is that all of these things live within the same code base. There are shared fixes and shared optimizations. If you make an optimization in an algorithm for one platform, it benefits all the platforms. Similarly, if we have, classic and survival tests or classic and in-dev, and underneath that, in the engine layer, we find a way to make the graphics, 10% faster. That 10% faster change goes back to the old version in Classic, as well as for the new versions. Completed phases stay in the source tree and continue to get live updates. The next thing is the architecture. So this is where it really begins. Choosing the systems that you can keep forever and designing things with the future in mind. One of the big things in the older version of CrossCraft that has been rectified is that we're reusing the core code. Instead of thinking of the game as being the single player version and the multiplayer version, which a lot of ports of different software through the PSP has thought of before, this with that, we keep it as one coherent unit. There is one core logic. Whether you're in single player or multiplayer, you're going through the same shared runtime. You're going through the same internal client, you're going through the same internal server, and speaking the same protocol. None of these things change, regardless of if you're doing networking or if you're just playing locally. So keeping this one shared code path keeps the code very lean, very simple, and it's easy to update for years to come. You don't need to duplicate changes. This was one of the bigger issues with the old implementations of Classic, was that you would have a separate server version and a separate single player version, and then the two behaviors would diverge, and that would end up being a problem. So by keeping this together as one thing, we have one lean code body, and it's very easy to update, and any fixes that you make apply to server and client. CrossCraft is also architected in sort of vertical structure as well. So CrossCraft is the top level. It's the highest level of abstraction, followed by Aether. Aether is our game engine. And then below the Aether engine are the individual platforms that we build for. So that's desktop, so Windows, Mac, Linux, PSP, 3DS, Nintendo Switch, and web. So as you can see by the diagram, the world, the protocol, the UI, gameplay, all that stuff stays within the high level realm of just the basic game logic. I want to place a block. I want to build a mesh. I want to draw this. Aether is the one who has the engine systems. So things like, well, how do you draw a mesh? And submitting it down to the platform level, and the platform level does the actual work. To add a platform to Aether, if you add a platform to Aether, essentially you get 90% of the work done already to bring it to CrossCraft. The second that it passes all of the Aether tests and has all of the necessary things, all you need to do in CrossCraft is some basic stuff like setting up a configuration, like, okay, how many chunks do we want to draw? How much memory are we allocating? What should be the button mapping? Things like that. Very, very simple integration work. So yeah, for our engineering philosophy, we follow the footsteps of giants. We're not here trying to invent anything new. We're pretty much taking from some of the best projects and best management infrastructure, and even if we emulate only 30% of that, that will make the code base a lot better and a lot nicer than most other ports, for example. So CrossCraft selectively borrows from NASA's Power of 10 rules for safety critical software, and from Tiger Beetle's Tiger Style. And if you don't know what Tiger Beetle is, they are a financial transactions database written in Zig. They're highly correct. They completely passed a lot of the formal database verification stuff with flying colors, and they write some amazing software. So part of this philosophy is asserting invariance, keeping important assumptions explicit and checked, including in release builds. So we release and release safe. If anyone happens to come across a bug, we can get a full stack trace of that, and we can be like, okay, well, we're going to fix this. We're going to see how this came up in production. The next thing is bounding work, putting limits on loops, buffers, and blocking operations. More so on the blocking operations side, we don't want things to block and stall. That causes a lot of just wasted cycles. And when every cycle counts, like on the PSP, that's very important. The third thing we do is allocations deliberately. So for the server side of things, we do one allocation. There is no allocation after the fact that we're not doing dynamic memory management on the server side. And then it's very limited what is dynamically managed on the client. And that's really just the chunks themselves. They have a fixed pool and they can grow and shrink. And we have no known memory safety or memory exhaustion bugs with that. This leads to some pretty good numbers. So for example, the internal server on PSP uses about 4.4 megabytes of RAM, and on desktop it's about 5.6. And the difference there is that desktop can have like 128 targets, which is why you need some more upfront allocations. We're also keeping the dependencies down to a very low level. We are basically only doing about one real dependency, which is the Zig compiler, and then any like per platform stuff is typically a dependency there, but we don't really count that as like anything else. You couldn't run the game otherwise. Like you couldn't run without Vulkan. So we favor having code that we control and a very small runtime stack. So another part of this was building the UI. We wanted to do controller first, and this was really pushed by Cypress. We basically map inputs to actions and not to devices. So in previous versions of CrossCraft code, we're checking, hey, did you press W on the keyboard, or did you press a key binding that maps to a keyboard? In this case, we're just checking, hey, did someone press forward? And then we're doing a second layer that translates, well, what is forward? Is forward an analog stick? Is forward a button? These are the different sort of things that we do. And the game responds to the user's intent. We also have this like prompt strip system, which you can kind of see in the bottom here, where it tells you, hey, you can either select the block with A, because these are Xbox controls, or B, and it's visible when the player needs it. Actually, I stand corrected. I believe this is I believe this is Nintendo controls. So then the ecosystem, and this is a bit more broad. Compatibility is a player feature. You should be able to take your save from your PSP and put it on your PC, and that should just work. Worlds and servers should outlive the hardware that created them. So some interoperability, bringing PSP to the Classic ecosystem. Classic World is a world format. It's a community adopted world format using named binary tags, NBT tags. And Classic World Saves keeps the worlds portable and usable with existing tools. So if you have a tool that allows you to edit Classic World saves from like Classic Cube or any of the other like Minecraft Classic ecosystem, you're able to use CrossCraft worlds straight out of the box. There's nothing else that you need other than just the save file. We also support the Classic protocol, so of course we can talk to any of the existing servers. We don't support the extended protocol yet. That is a future addition, which allows you to do like some modding stuff, which can get very difficult on PSP. And also having one project tree, like I said, means fixes and optimization progress does not stop. So here I have a bit of a playable demo, and it should play. that render distances that no other PSP port has matched. This includes 6 chunks at 30 FPS on the PSP Slim, or up to 4 chunks at a smooth 60 FPS on the PSP Fat. It has the lowest latency multiplayer on PSP. Just connect and play. You can even host a server on another PSP in case you don't have a PC. And if you want to, you're not locked to CrossCraft. Any Classic compatible client works, including Classic Cube on the desktop, or of course, CrossCraft on desktop. Yeah, so that's just a brief demo of some of the features of things that you can do in CrossCraft right now. CrossCraft 1.0 is out and 1.1 just released. I still have to make a video on that. It's been about like a week since the release. And here we're going to talk about some of the stuff that's soon to come. So the next version is 1.2 of Classic. It's the last Classic version before we move to Survival Test. That doesn't mean that Classic won't be supported. As I said, it's going to continue being supported. So one of the cool features that we did was that we started working on reverse engineering of the Minecraft world generator. Nobody has a like perfectly block identical version of the Minecraft classic.jar world generator yet. And I was actually surprised to find that out. So me and a buddy, we basically worked together and were able to reverse engineer it. So world gen from the classic 1.10 jar, given the same like input seed, which you can control through an oracle, it produces the exact same world data byte for byte. So the exact world that would be generated on the PC from Java is being generated on the PSP and on any other platform from CrossCraft in the exact same way. We did this using Lean 4 as the specification language to specify the Lean 4 was not executable in any way. And this basically allowed us to create a mathematical algorithm which specifies how the world was generated. And then we implemented it in Zig. And this was able to be verified for the world data. And then we went ahead and optimized that on the PSP. On the PSP, we got world generation time down to 3.4 seconds. Currently, world generation time on 256 by 64 by 256, if you downloaded version 1.1 right now, it's about 9.7 seconds. So it's even faster than the existing world generation, and it's byte for byte identical, which is really cool. And this byte identicalness was tested on a server with 384 threads, running full stop for like 12 hours, and we tested a total of 17 million worlds, 29 trillion blocks, and none of them deferred at all. So yeah, that's an upcoming feature in version 1.2, and version 1.2 server will be coming out soon, probably within the next 2 weeks or so, and then the client probably within a month. Yeah, so also for if you want to build it yourself, if you want to work on the project, contribute to it, we have minimal dependencies. All you need is Zig 0.16. If you have Zig 0.16, you can pretty much do it. Do anything. You just clone the repo and the resources as well. You need the resources. And yeah, you just run in the terminal whatever you want to compile. So you can build it, just build the game locally. You can build it for PSP, 3DS, Nintendo Switch, or web. And this is due to Ether Engine. So PSP is powered by Zig PSP, which is my custom toolchain for Zig on the PSP. Zitrus is for the 3DS. It's written by Gas Infinity, who actually helped a lot with Ether Engine and getting CrossCraft working really nicely on the 3DS. So a big shout out to him. And then Nintendo Switch is through DevKit Pro, and the web is actually just the native Zig WebAssembly backend. So Classic version 1.2 is obviously the next version. It will have a feature for cross-platform servers. So basically, you'll be able to join from your PSP, your Switch, your 3DS. You already can, but this expands greatly the ability to do it. We're going to do things like having a server browser inside of the actual game itself, so you can join. You can log in with a Classic Cube account. You can join Classic Cube servers, or you can log in with a CrossCraft account identifier, and you'll also be able to play on CrossCraft servers as well. Some of the main features of Classic version 1.2 is plugin support, so that's mostly for the server, but this allows you to write your own things using a luau, and you'll be able to make games like Spleef and Build Battle and whatever else you want to do. You'll have a customizable API for the server side of things. It won't be like when you're doing like a single player world, you won't have that, but on servers you'll have that. As I said, the byte identical world gen. We're also increasing the ability of players to have bigger worlds. So on the PSP 1000, that'll be 512 by 64 by 512 is the maximum size, and 512 by 128 by 512 will be the maximum size on the 2000 plus. And this is only really a generation side constraint, not really a memory constraint, because what we'll be implementing is world streaming, and world streaming will be using basically just taking it from the disk, using an LRU page to page in and out, the different parts of the chunk that you need, and that's how the world streaming is going to work. This will actually reduce our total memory usage as well. Projected right now on a 256 by 64 by 256 world, you would go from about 4 megabytes, which is current, to somewhere around 1.5, 1.6 megabytes. So it will be a universal sort of savings, and things will stay around that size. It's basically going to be the size of your render distance, plus a little bit of an offset. And of course, the better multiplayer, as I mentioned. So yeah, that's CrossCraft, and here's the questions section. We also have a website, which is crosscraft.io, which you can use with the QR code. That contains links to the GitHub, Discord, and an overview of basically what's going on. We have our server list up as well, but we don't have a server yet set up. That will be coming with 1.2 as well, is that we'll create a official CrossCraft server instance for people to play on. So yeah. Oh yeah, on the hosting a classic server on a PSP, that was mostly a demo. You can still do it. There's going to be some things that you need to change with the current source. We decided, at least for the practicality of having a better server experience on PC, that we were going to not build the server on PSP as much. But we are planning an open to LAN feature. So that would be basically a drop-in replacement. You would be able to open to LAN from your PSP and then have like another PSP like join you or something like that. And that will be the server story on the PSP. We also thought about ad hoc. That might take a little bit longer though. So it might not be a version 1.2 thing. Yeah. So instead of just running like the full fat server, you'll run a thinner version of the server, basically. Question: what do you think is the weakest device that you can imagine that would be capable of running CrossCraft? I mean, honestly, the PSP is a pretty good spot. I don't know, maybe a GameCube. I know it has 24 megabytes of RAM. The biggest thing that takes up a lot of space is meshes. You can go even smaller and do like sub meshes, and at that point, or sorry, sub chunk meshing. And if you were able to do that, you could go smaller. But for the long term, we think PSP is going to be better for infinite worlds and things like that. Because you have to remember that we're also thinking about when we're doing world gen while like the world is running. PS2 would also be possible. The reason OG Xbox is a better example. I think OG Xbox would be a lot easier to do. PS2 would also be possible. It's just that the PS2 toolchain situation is not like that amazing, and there is the penalty of compiling Zig to C. So for the Nintendo Switch build, there's no like native Zig build. We compile Zig to C because that's just the thing that you can do with Zig. And then we link against the C libraries and stuff. And that works pretty well for the Switch, but you know, the Switch is also just powerful enough that like it doesn't necessarily matter that it's the most efficient or not. The PS2 would really push that, and we would probably need our own like toolchain to do that. Does it support ad hoc multiplayer on the PSP version? I mean, I kind of covered that. That is potentially a future feature that's under consideration. But for the short term, I would say no, but not necessarily. If you think like within a year, it's definitely like possible. But it's not like within the next like month of development. And yeah, we do have the World Gen byte to byte. Let me just check the Discord if anyone else has questions, and then we'll move on to the Star Fox 64 demo. One last question. How far will you take the project? Will you reach the state Minecraft was in around 2015 or 2016? I do not know off the top of my head what 2015 or 2016 was for a Minecraft version. Is that 1.12? Or is that, no, that's like 1.8, isn't it? Hold on, I need to look this up. Sorry. That is 1.8. There are certain considerations. We don't necessarily have a full like end state version yet. Well, obviously like 1.0 is like the main goal, right? Official 1.0. 1.1 I think raises the sky limit. So there's questions on if 1.2 will be memory efficient enough. But if we could get 1.2.5, for example, official release, that might be a stopping point. I think 1.5, 1.6, 1.7, 1.8, it might be possible. I'm not going to make any hard commitment on that question, so unfortunately I'm going to give you like the politician answer and say official release 1.0 is the currently slated like final resting version that we would care for. So the next presentation will be Star Fox 64. This will be presented by the Mr. Iron 2. He's like the administrator of the PSP Homebrew server, and he's just been in the scene for a very long time. And yeah, let's go ahead and see his presentation on porting Star Fox 64 to the PSP.
Hi everyone, my name is Daniel Welch, or the Mr. Iron 2, and I'm here today to give you a talk about my work for Star Fox 64 being ported to the PSP. So first, a little bit of background. I remember emulating this game on a Mac Mini G4 when I was a kid, And I bought a 3DS for this game when I was about 10 years old. It was a formative influence on me, I suppose, seeing that magazine. So with the PC port, Fox and the new Mario movie, and the 64 remake that's just come out on Switch 2, I decided I'd start trying to port the game to the PSP. So Star Fox 64 was decompiled in 2024, and it got 2 PC ports shortly after that. The trouble is they both rely on very modern code that doesn't suit the PSP. For one thing, they rely on very modern renderers like DirectX and Vulkan that we have no equivalent for. And they also have very heavy frameworks for asset loading and modding. They just require too much memory. Our closest graphical match is pspGL, which is effectively OpenGLES 1.1. But we have other useful legacy references. We have Mario 64, Perfect Dark, and Ocarina of Time already ported to the PSP, 2 of which are under pspGL. And we have the excellent Sega Dreamcast port of Star Fox using a legacy OpenGL renderer as well. So I decided to work from the decompiled Nintendo 64 source and adapt some of these solutions. So here are my initial attempts to adapt the Nintendo 64 source directly to the PSP. It didn't take me long to get the first signs of life at all. I could see the first real 64 code booting up, to my great excitement, and the first 2D elements, which were a huge milestone, because this was effectively reassembling the Nintendo 64 pipeline with the native PSP GUI API from scratch. So it was an enormous undertaking at the time, but I felt really good seeing every piece come together. So a couple of early obstacles. I knew from my experience with Perfect Dark on PSP that a big hitch with these Nintendo 64 ports is lots of tiny little draw calls, and I suspected that we were going to have a problem with that with the Starfield in the background. So I devised a quick approximation very early on that was good enough and batched the stars together. As you can see from the photos though, transformations were all over the place on 3D elements. It was really hard to make the PSP understand the 64 math because the assumptions around it were different. And the intro cutscene had to be skipped entirely during bring up because any real 3D would crash the renderer. But piece by piece we were reassembling the 64 pipeline from scratch for PSP. There were a couple of steps back as you went forward, as you can see from the photos. The 64 logo would occasionally disappear as I was trying to do this. It was also really slow. It was a few frames a second maybe. As you can see, I commented out the Star Fox team, the 4 that are meant to be standing in front of the R-Wing, to just try and get the R-Wing itself rendering correctly. And after about 10 days, I had achieved a correct-ish R-Wing. Not perfect, but very recognizable. But eventually this first principled renderer became harder and harder. As you can see from this screenshot, the assumptions around the Nintendo 64 code were just becoming very complex, so it was hard to reconstruct that pipeline natively on the PSP. Not only that, we were still slow and missing graphics. So instead I thought, well, the other 64 ports to PSP all borrowed from OpenGL, at least at first, and then built onto the PSP. So I decided to do exactly that, and I adapted using pspGL. And just 24 hours into this effort, I got pspGL up and running, and as you can see from the video rolling at the top, it was stable and very recognizable on a scene that was previously crashing. And that's the thing, the textures I fixed in just a couple of hours, and the shadows I fixed with one line. Because ultimately these problems had already been solved in an OpenGL renderer elsewhere. So this pivot was absolutely the right call. And just 3 days later, the game was already starting to look like this. So as you can see from the footage there, we were already getting really close. It was around this time we got the first real gameplay on console. Corneria would crash, but we could get into training mode just fine, and it gave us real gameplay at about half speed, which was a fantastic thing to see this early on. But at this point there was still no audio, visuals were incomplete, and the Ultra 64 code beneath it was adapted straight from Dreamcast, so we weren't there yet. It was around this time I started to think about how we could adapt known good code from other Nintendo 64 ports on the PSP. That means a good implementation in one game becomes a good implementation for all. Instead of me having to borrow parts from Mario and Zelda and Daedalus, if we had a library, any 64 game could import and use good code out of the box for PSP. And so I started to design a library to do exactly that. The idea here is we get the best performance with reusable and well-optimized code. And we had good references for this already. Daedalus has some really good Bajor solutions to these Nintendo 64 questions, like some really nice low-level use of the vector unit. Mario 64, Zelda, and Perfect Dark all have common parts that we can reuse. But first, we had some real game-specific problems that we wanted to fix. The first and most obvious one is that our code was really slow. So I set up some profiling to write out logs of what's happening inside the PSP. The title screen was comically slow, it was less than 5 frames per second, whereas training mode was ranging from about 12 to 20 frames a second. So something or some things were really challenging our code. The title screen alone, as I said, was really slow. So why was that? Unsurprisingly, a predominant problem here is that the PSP was breaking the work into hundreds of tiny little pieces. The PSP wants batches. Think of it like a moving van. It's inefficient to put one piece of furniture in a van, bring it back, then forth and back. You want to fill the van up to save the most time. A change in graphic stage ends the batch and starts another. This is called a flush, right? And on the title screen, the renderer was interrupted to make a batch over 600 times in one frame. And 613 of those were texture changes, many of which were completely preventable. And so I ended up solving the bad batching because there was a GL specific bug. A set image command was causing premature batch breaks. What's more, I implemented VBO streaming, which made the remaining batches much cheaper. So instead of a fresh CPU array for each batch, I copied the batches into the GPU and draw from there. But performance is still low. Even though we were down 71% of flushes, the title screen was still barely faster. And as the next profiler revealed, it only exposed the real bottleneck, a cache problem. So what I found is that the title screen needed to cache 76 textures. The problem was I'd provisionally set the limit to 64 textures in a cache. And that caused a loop, because the cache would fill up to texture 64, it would run out of room, then start evicting the start of the cache again, so it just kept going in a cycle and would fill up. So we were only 12 textures short of a full cache, but pretty much all of the misses in this capture were reloading textures that should have been there in the first place. Once that was solved, the next optimization I implemented was a fast track, or triangle fast path. Effectively, the game would do a quick check to see if triangles were already fully inside the visible region, so they didn't need to run the expensive clipping code. And most triangles already were. That bypassed a lot of maths and sent the triangles directly into the rendering path. So after the cache fix and the triangle fast path, we had made a lot of progress. The title screen was twice as fast, almost 100 milliseconds. But even that was still 10 frames per second, so the bigger optimizations were still on the table. And that's where the VFPU comes in. So the PSP has this chip called the VFPU beside the main CPU that helps to accelerate a lot of maths calculations. So instead of processing some of this one value at a time, the VFPU can operate on entire vectors and store frequently used matrices, so the arithmetic is enormously faster on this unit. As you can see from the benchmarks, it was 2 to 8 times faster for lighting, transforms, and matrix multiplication than the main CPU. And because it's implemented into the library N64 PSP, every Nintendo 64 port to the PSP can take advantage of this speedup. Granted, a lot of this code was already in Daedalus 64. It's adapted pretty much verbatim. But the benefit of this is that we can abstract it and put it into every other 64 port. So after just a day of optimizations, the title screen fell from 216 milliseconds to 112, and then the VFPU accelerated us to 46 milliseconds, which is huge. But here's one potential pitfall, and I'll isolate this particular function. So there's one VFPU instruction that can calculate sine and cosine together. Compared to doing this on the main CPU, this is 7 times faster. And in some cases, this made game update code fall from 15 milliseconds to 4 milliseconds. That's on the title screen. Once you go to the map screen, not only is it performance neutral, the game actually ended up slower. It's not because this is a slower operation, but the frame was being limited by so many other things that this was irrelevant, and minor changes like the layout of the binary ended up making it slower. In other words, this was not limiting the frame in this scenario, so this speed up, although 7 times faster, meant nothing in other scenes. And now this is my favorite, or maybe least favorite bug of the whole thing, right? So Corneria's opening cutscene had a bug where a thin blue streak would appear for 1 frame during the intro 3 times. I went through pretty much every suspect I could find. The clouds, VFPU transforms, clipping, texture rectangles, degenerate triangles. But after looking at it through PPSSPP's debugger, it appeared before any real geometry. And so after literally 23 rounds of trial and error with instrumentation, the answer was none of them. The problem was our renderer was too precise. You see, there's a blue fill behind Corneria's skybox. That's what the blue streak actually was. The skybox is 2 different parts being welded together. On N64, the coordinates are rounded and they snap together. But on PSP, we were trying to calculate this too accurately, which revealed a difference of just 1 pixel for 1 frame. So this blue streak was none of those things. It was a rounding error connecting the 2 halves of the skybox, and it was invisible to every single round of debugging and instrumentation because there was nothing to debug. My code was working too correctly for the original game. So where do we go next? As you can see from this clip here, the game is full speed with media engine sound, or very close to it, and without sound, as you can see, it's a walk in the park. At the moment, I'm exploring using the Virtual Mobile Engine, or the VME, for audio acceleration. This is a chip that, thanks to MSID's work on GitHub, we've been able to really understand for the first time in the console's life. This could exponentially improve the speed of audio processing. Particular operations are up to 24 times faster than doing it manually on the CPU. As for the port itself, with sound off, it's a perfect 30 frames per second. It's often closer to 60. And I'm targeting the end of the year for a full release for a polished and finished product. So in conclusion, the goals for this port are very clear. A high-performance renderer both using PSPGL and native GUI code. And the reason for this is because I want to see for educational reasons the differences between the 2 renderers. I think this would be a great benefit to the scene at large to be able to compare them both directly. PSPGL has a lot of limitations that the more native code of GUI would not, but it's important to see and acknowledge that PSPGL has its own advantages hugely when it comes to porting external software, and see how close they can really get in a well-optimized scenario. VME sound acceleration is hugely hot on the cards at the moment. I'm really excited to see how much closer we can get to full speed sound under PSPGL, because we're already really close even before we get the higher performance renderer. I want an overlay to be implemented. At the moment, Z2442 is working on one for Ocarina of Time, and I'd hope to be able to include options like aspect ratio, the renderer backend, framerate cap, controls, and all the works from just a touch of a button in-game. So the future is very exciting, and as Fox McCloud would say, let's rock and roll! So thank you very much everyone for watching, and I hope to have more to share about this port very, very soon.
Wow, that was a great presentation about Star Fox 64, and I've been excited to see it develop every day in the N64 Ports channel in the Homebrew Discord server. Good job to Mr. Iron. Our next presentation will be by Andrew about making a game engine for the PSP.
Yeah. Can you hear me good? I hope my mic does it. Yeah, action. All right. Hello, everyone. Welcome to my talk. Today I'm going to be talking about the issues I faced when making a game engine for the PSP. Because I decided to make a game engine for the PSP for no particular reason. And I'm sure this is like the 7 billionth open source game engine made for the PSP, so let's just get on with it. But first, who am I? My name's Andrew. Online I go by Slash. I don't have some sort of like stacked portfolio or anything. I just like programming in my free time. And for some context, I used to do a lot of front-end development, but recently I've started working a lot with lower level languages. Okay, and I just want to do another quick overview. Like, I'm sure everyone knows this who's watching this already, but I want to do a quick overview of the hardware that I'm working with. So this is the first iteration of the Sony PSP, the Model 1000, and then later on, Sony dropped, oh, my bad. Yeah, so we have a 40 by 272 LCD, and we have a 333 megahertz MIPS CPU and 32 megabytes of RAM. And then later on, Sony dropped the Model 2000 and 3000. And the most important difference in these models is that we have 64 megabytes of RAM. Right, so what about actually making the game engine? I'm going to give everyone a question to ponder on. What would the ideal game engine for an older console look like? Now, if you ask me, I would say something like Godot or Unity, but it would just compile to the older platform. And this is kind of what I tried to replicate with my game engine. Before I start my long spiel about how my game engine works, I want to show everyone a fun fact about my game engine. The variant I will be talking about today is actually like the third rewrite of this game engine. And when I originally started working on it like a long time ago, I did not know any C++. It's got some footage of the older version. Now, this version was really bad. It was really badly structured, and that's why I had to do a rewrite. I mean, you can just imagine the worst piece of code you've ever seen, and that's pretty much this. So because of this, I knew that I had to plan out the structure of my game engine really well before starting work on it. So let's talk about the structure. Personally, I've always liked how Unity works in regards with entity component system. Now, in an entity component system, you have entities, which have components. And then you have the system part, which gets you a specific entity, among other things. However, when you're developing for such an old system, you kind of don't have the spare CPU cycles you need for that, so I actually don't have the system part. So we can just call it an entity component, I guess. So then let's take a look at how I did this in my game engine. So I call them nodes. I call entities nodes because it sounds cool. And they have a name and they have an array of children and an array of components. Probably the more important thing of nodes is how does the game loop work with nodes? So we probably want some lifetime functions. That's kind of critical. So let's add some. So we have update, initialize, and exit. This isn't exactly the code that's used, but it's kind of like a pseudocode version so everyone understands. So let's take a look at the component struct that I use. So it's basically, it has the same component functions, lifetime functions, that the node does. And we also want a way to link back to the node. Using this structure, I created a sprite component. And would you look at that? It's the first ever screenshot of Calamity Engine, and I decided to call it that because it sounds cool. This kind of when I started development on it, it was in like January, I think. Let's talk about the node tree really quick. in Calamity Engine, every window has a root node, and this root node contains every other node in the game. Now, if you guys remember the lifetime functions I mentioned earlier in my node, those are recursive. So if we want to exit the game, for example, we can tell the window I want to exit the game, and I'll call the exit function on the root node. And then the root node will call the exit function on every other child that it holds. Now that we have this concept straight, I want to talk about the big pain in my ass, which was making two nodes rotate together properly. Let's go back to the node. Of course, we want some position, rotation, and scale data, right? So let's make a transform class. So we have a regular transform and a global transform. Now, what should we put in this transform class? Well, when I started working on my game engine, I didn't really know much about making game engines. So this was my solution. Now, if you're keen-eyed, you can probably already spot the problem here. The issue I was facing was that child nodes were not rotating correctly around their parent node, like this. And the reason this was happening is because I didn't know I was supposed to use a transformation matrix to represent the scale and rotation of a node. I really don't know how much time I spent trying to make the matrix-less version work, because for some reason I was really scared of matrices. This is a transformation matrix, by the way. Turns out they're not really that hard to use, and eventually I got it working correctly. Would you look at that? Another video. So another big head scratcher for me was serialization in scripts. Let's talk about scripts first. In Calamity Engine, scripts are a really simple wrapper around components. And honestly, the script class probably shouldn't even exist because it's literally just a component class, but it's fine. Anyways, with this class, you can make a script like this. So this code would sit in a header file. And as you can see, we're inheriting the script class, and we're overriding the logic of the lifetime functions. We're overriding the logic of them, right? It's our own logic. And this is very similar to how Godot or Unity would handle these scripts. And since scripts are just components at the end of the day, we can add them to a node like this. So we have the node and we can add the component, which is our script. So let's talk about serialization and deserialization. And it's one of the most important things you can have in a game engine. Now, doing serialization in C++ on your own isn't really fun. It's not the most fun idea. So one of my friends actually introduced me to this library. It's called Serial. And the pitch for this library is that it handles everything related to serialization for you. But to serialize a class, you must add some logic to it, related to it. So you have the save and load function. And I mean, you don't really have to understand how it works, but I don't really need to either. But basically, you have control over the data that you want to serialize and deserialize, or save and load. And because of this, we have this level of control. But when I was implementing scripts, I was really scratching my head because the user defines the data in the script class. And I was like, well, how do I know what data the user defines? And you know, we have to take a step back to look at this, because Unity and Godot, they're running on modern hardware and they have modern language features and stuff. And what I mean by this is that, you know, Godot has GD script. It controls the language. It knows. Unity has C#. It also kind of controls the language. It also knows. We do not at all. We don't have any of that stuff. We have C++. I mean, for us, the game, for me, the game compiles along with the game engine. So we don't have a way to look at that stuff. And I was pretty stumped until I realized I could just make the user do it. And what do I mean by this? Is I just make the user define the save and load functions. Because if you think about it, I guess you could say this is a bit more annoying to do, but you have a level of control that you kind of want on this kind of system, on this kind of platform. Because maybe you don't want to save everything or load everything that you saved. So overall, I think this is a good thing. And here's another video, this time of deserialization working. I'm loading these nodes that are spinning from a JSON file. Okay, let's talk about documentation, because nobody really tells you how to write documentation. I guess it's kind of a silly thing to presume that there are resources online about, because, imagine a documentation website telling you how to write documentation. But, Godot is actually a really good resource for this kind of stuff. Like, Godot documentation is really good. So I just kind of inspired myself from that. And here are some things I learned. So number one, you want to cover everything. If you're writing documentation for a class, you want to speak about everything in that class. And then number two, we want a lot of code examples. So my approach to this was to have both a lot of code examples in the documentation and to have a lot of interactive examples that the user can play around with, so that they can learn how to put those concepts in practice. And I actually managed to get these examples to run on the web with mscripten. It was a bit of a pain because mscripten is always a bit of a pain, but I'm happy I got them to work. And now, because we're talking about mscripten, let's talk about actually making the cross-platform game engine cross-platform. So let's go back to the first ever screenshot of Calamity Engine. You need to look closer. So as you can see, it is running on PPSSPP. And this is because originally I made it so you could only build it for a PSP. Later on, I realized that debugging on PPSSPP, I don't want to do that. So I made it build natively for Linux. And this is still a really early version of the game. So as you can see, it's because the nodes still don't rotate correctly around one another. And also it's running on my phone on Termux. That's why it's running so bad. And then, I made it run on the web using mscripten. And as much as I like saying that mscripten is bad, there is something that is much, much worse than mscripten. And I mean, I want you to imagine the worst developer experience possible that you could ever have. Mscripten doesn't hold a candle to this. Mscripten likes to complain about some really specific stuff, or it just doesn't want to compile sometimes. But hearing the name of this compiler strikes fear into my spine. MSVC. I don't think you want to hear the things I would rather do than put up with MSVC for one more second. But instead, I can tell you why I hate MSVC with all of my heart. So let me ask you this. Would you rather do your cast like this or your cast like this? Well, with MSVC, you don't have a choice. You don't have a choice at all, because if you do C-style casts, it blows up. It doesn't want to compile. And on Windows, you have to build every vendor library yourself, because you can't really install a library easily on Windows. So that means compiling a game on Windows will take like 4 times the amount of time it would take to compile normally. Okay, let's slander another homebrew SDK, because obviously the PSP one is the best. We can all agree on this. So Calamity Engine depends on some libraries such as SDL3. We have Serial, Box2D, and SPDlog. The thing is, I would rather have the user not compile these vendor libraries when they're doing with the homebrew SDK. I would just rather not have them compile them at all. Unfortunately, on some platforms, that's not possible. But usually, homebrew SDKs for consoles, they have some sort of package manager to solve this issue. So DevKit ARM, which is the 3DS homebrew SDK, it has a package manager too, but unlike PSP SDK, I think they forgot how to use the merge button. 23 open pull requests. Nice. So I had to make my own Pacman repository just to add 3DS support. And after struggling to get every single dependency to compile properly on the 3DS, guess what? SDL3 on the 3DS only supports software rendering. So that means every game with more than 2 sprites on the screen runs at like 15 FPS. Here's an image of the platformer example running on my PSP. It's a Model 2000. One more thing. And you're gonna have to bear with me for a second. So I want to talk about this thing called Hack Club. They're a non-profit company from America, and they run these online programs for teenagers where if you just work on your personal projects and log what you're doing, they give you prizes. And I guess this is kind of like a sponsorship disclosure, but Calamity Engine was enrolled into one of these programs. So as you can see here, I logged like everything. I guess if I wasn't participating in this program, it would have been a lot harder to make this talk, because I wouldn't have had this documentation about my game engine. I'm really thankful for them existing because from working on Calamity Engine, I managed to get a Framework 12. Here's proof. And as you can see, I also like stickers a lot. They have a lot of stickers that they give you. And right now, they're running their biggest program yet. It's called Stardance in partnership with NASA, AMD, and GitHub. And you can fact check me too. Here's NASA's website talking about it. And then here's AMD's website where they talk about it. And the reason I'm talking about this is because this is a great opportunity for anyone who's under 18. And I want a lot of people to know about this. I'm not being paid or anything. If you're under 18 and you like programming, you should definitely check them out. You should scan this QR code. They have a community of really passionate people about this stuff. So, thank you for listening to me ramble. I have a QR code of the website for my game engine up there. There's like examples and everything's documentation. And I guess I would be thankful if somebody would check it out and decide, hey, I want to make a game using this. Who knows? Maybe somebody will recreate Space Station 13 on the PSP. That would be kind of cool. One day, maybe I'll get to see a cool game made with my game engine. But thing I ask is, does anyone have any questions?
And while we let the chat go ahead here, thank you so much for giving this presentation. I know a lot of people in the chat were really excited with all the different transitions that you had, alongside of some people having done Hack Club themselves.
Yeah, let me check out the chat.
There is like one question about does the 3DS SDL3 does only software rendering? I think that's just more of a question though.
Yeah, it only does software rendering. It's really weird. And I don't think I want to implement it myself really. I don't know any of the 3DS homebrew stuff, and I do plan to get this game engine out on more platforms. I want to get it basically wherever SDL3 compiles. I think it's possible to get it. PS2, for example, that's one. Original Xbox, Xbox 360, whatever.
Yeah, that's really cool.
Yeah, thank you for having me to the talk. Thank you.
Yeah. Where do we ask questions in the chat? You ask questions in the chat. You can also ask them on the Discord if you've joined. That should be in the description as well. What do you think is the hardest thing you got through making the game engine that you won't be able to avoid anymore?
Won't be able to avoid it anymore.
Yeah,
So that's
I think is there anything that you like skipped that now you need to do? I think.
Oh, audio, because when I made the original version of the game engine, I was using SDL2 mixer, and I don't like SDL mixer at all. I probably because I don't really know how to use it. And I have to do audio now. One thing I also had to do, I didn't talk about it, but originally you were only able to have one window in the game engine, but when I had to port it over to the 3DS, I had to implement multiple windows, and that was a bit annoying to implement because I had to like split everything up. And also I see somebody ask if I aim for a 2D engine, 2D or both. It's only 2D. It's only 2D generally because I mean I'm not big into 3D. Like I don't know any of the rendering APIs for 3D stuff at all. So it's just generally just 2D.
Yeah, I see. And then for the 3DS, there was a suggestion of using Citro 2D. But yeah, Citro is pretty low level as well. So you might as well just also learn to use Citro 3D at the same time. In which point you're learning the entire 3D stack.
Yeah. I guess I was told by a couple of people, my friends, that I should probably have like multiple render backends, like I should just use OpenGL straight up. But the issue is it's like so tightly integrated with SDL, I can't really do the switch now.
I see. Yeah, I'm not sure how STL and native like GL compat is on other platforms other than the PSP, but I think it generally works decently on the PSP. Waiting for a couple more seconds, but if there's no more questions, thank you so much for giving a live presentation at this year's PSP HCC, and we hope to see you in the future.
Yeah, me too.
Okay, so the next presentation will be the Neon Genesis 2 localization by Main Void. And without further ado,
hello everyone, it's the Only X here. Today I'm gonna give a small presentation on Neon Genesis Evangelion 2 Chinese localization. So first, let me briefly introduce the Chinese fan translation history on PSP here in China. So there is a word called Hanhua in Chinese, which literally means Chinese lies something. You can consider it as Chinese localization. There are roughly 600 games on PSP that have been fan translated into Chinese, which is a large amount compared to English translations. I found on romhacking.net there are like about 60 games that are translated into English. So most of these Chinese translations were done in the 2010s when the PSP was the most popular handheld in China, and most of these Chinese translations are based on Japanese versions. Nowadays with LLMs, more games are now being reverse engineered and translated than ever before. Next, I'm gonna talk about the challenges in Chinese translation. So for English translations, the problem usually lies in memory. The Japanese characters and the Chinese characters, they can represent more meaning than English characters when they use the same bytes. For example, on the screen, we have the same sentence that means I drink water. Chinese only takes 6 bytes and Japanese takes 8 bytes, while English takes 13 bytes. So to avoid overflow, a lot of remapping on memory layout and a lot of redirection of the pointers are needed, and that's a lot of work. Yeah, but the Chinese translation, they have it has a different challenge. The main challenge is encoding and fonts. So in the Shift.js encoding system, which is most commonly used by PSP Japanese games, there are like 6,000 kanjis, while in GB2312, a subset of the current Chinese standard, it has 6,700 commonly used Chinese characters, and only about half of them share the same encoding in Unicode. You can see on the bottom right picture here, it's a picture of the GB2312 character map, and all the white ones are not present in Shift.js, which means when my translation want to use these characters, they cannot be represented by Shift.js encoding, which is a huge problem. So normally, what the Chinese will do is that first, we will reuse the Shift.js encoding byte scheme. So you'll count the characters used in the translation and change some of the Japanese font glyphs to Chinese glyphs, and as we describe here, the old character slots get new shapes. Then obviously we will generate a new byte-to-character mapping by changing the glyphs. And use this new mapping will encode the translated sentences and inject them into the resources. So on the right side, you can see the Shift.js byte ranges. It has single byte characters, the ASCII characters, the half-width katakana, and the double byte characters like kanji and kana. And usually we will replace the Chinese glyphs into the double byte range. The glyphs usually stored in the game as texture or bitmap. So we need to find them and change it. So finally, the game itself. So the game I've been working on for the past 2 years is called Neon Genesis Evangelion 2 Tsukura-Reshi Sekai, Another Cases. It was first released on PS2 in 2003 and then in an enhanced version released in 2006 on PSP. It's fully voiced with 37,000 lines of dialogue. So it's basically the definitive Evangelion game. Yeah. So any Evangelion fan would love this game. And yes, actually, it has been studied for a while. I mean, when the game was first released in 2006, there's a thread on the Evangelion Geeks community. So like as early as in the 2010, there is some proof of concept menu patch of this game. And later in 2018, the man called Razio, he creates the Neon Genesis Evangelion 2 reverse engineering repo. And he analyzes most of the file formats used in this game. Yeah. Then later in 2024, I forked Razio's repo and start digging into the code and reverse the binary myself. And yes, and I've discovered other things like the encoding conversion and design the whole patch architecture and so on. So I will tell you the 3 main challenges I met in this process. So the first is, as I mentioned before, is encoding and font. So the game is a little different from what I mentioned before. There is no bitmap or a glyph that contains all the Shift.js characters. Instead, it uses Sony's SymFont library, which makes things a lot easier because SymFont library actually takes in UTF-16 Unicode. So it is able to represent all the Chinese words, Japanese words, or English, or anything that we need. But the main problem is that the game itself, at least in the game resource files, it uses Shift.js encoding. So, yeah, of course, there must be a conversion algorithm in the game that converts Shift.js to UTF-16, and also a read, like when you read the file, when you read the Shift.js sequence, you will determine whether it's a 1 byte character or a 2 byte character. So we decided to hook this conversion function and also the read function. As you can see in this video, the Shift.js is a variable length encoding. If you still remember the lead byte size, whether it takes 1 byte or 2 byte. So we customize the Shift.js to UTF-16 parsing, so the range normally reads a single byte can also carry 2 byte sequences. So thus we borrow the unused code points to store the Chinese characters. Eventually, we'll be able to store more than 7,000 Chinese characters in this extended region. The benefit of this method is that it keeps the Japanese translation untouched. So untranslated Japanese text and translated Chinese can coexist. The untranslated Japanese text, they stay the same, and the game can interpret it without any modification. if we use the method we mentioned before, that we change the Japanese claims, the untranslated Japanese will just scramble and they become some random Chinese words, and they just combine together. The second problem is the word order. So in this game, there's a memory system. The game generates memory sentences at runtime from past events, and these sentences are composed from fixed templates. So in this example here, you can see, so the game will read the characters. Yeah, the characters are chosen by the game logic, and they will concat it with the with a fixed verb template. So in this example, it's Shinji ga jibun no tsuyoku dakishimeta. So if we just translate each part of the sentence, what we will eventually get is like Shinji myself hugged tightly, but that's not grammatically correct. It should be Shinji hugged myself or Shinji hugged me tightly. Yeah. This kind of things happen because Japanese use the subject, object, verb, so word sequence, the word order. But the English as well as Chinese, they will say first subject, then verb, then object. So that causes the problem. So how to solve this problem? Well, I figured out a way is that we could just we have to put the object into the verb phrase, because well the subject, it can appear in the middle of the sentence or at the end of the sentence, like said trivial things to me, to myself. So that's how we did it. So we introduce this curly brace B to represent where the object should be in the verb sentence. So for example, in the sentence we mentioned before, we can use the Shinji hugged curly brace B tightly, and then we will change B to what the yellow part should be. Yeah, we will fill it. We will just fill it into the phrase later, so it will produce a correct sentence like Shinji hugged me tightly. So this is how it works on the PPSSPP. You can see the grammar of the sentence is correct. Like Shinji told Pan 3 days ago, Misato became interested in Pan's words. The thing that Misato became interested in Pan's words. Okay, the third problem. The third problem is the architecture. Well, actually, the architecture has evolved many times, but I will just tell you the final architecture. It's basically inspired by the 0L voice PSP repo. So it contains a loader and a runtime. Basically, I changed the eboot to our own program. It's a loader. It will first load the game and the runtime. Then it starts runtime first, and the runtime began editing the game's memory. It patches the memory and it hooks some functions. Then and when the process is done, I will boot the game itself, and the game starts. And everything works fine. So it can like jump into the function stops in runtime and do other things. Yeah, here is basically it's basically the same as I've mentioned. You load the two modules, start the plugin first, and patch the game, and then boot the game. So here is a simple demo of oh my god, why is it not working? So this should be a demo of the game running, and on the left side it's the contributors. Well, I'll paste the video here when it's done. So yeah, okay, and there are also other Evangelion games on PSP that I've translated into simplified Chinese. Some of them are translated by AI, by DeepSeek, ChatGPT, but well, they are playable. Yes, they are playable. Yeah, but for this game, I think I will deal with it seriously, and actually I'm still working on it, and many people are still proofread the sentences that are pre-translated by AI. Yes. And finally, I want to give special thanks to the following projects. Razio's original repo. Without him, the analysis of this game wouldn't be possible. TPU-Nix PGF tool for the font generation, because the font shipped with the PSP, it doesn't contain all the Chinese characters. So you have to reassemble a new character file that contains all the characters you need. Yes. So yes, the SymFont library, it supports all the UTF-16 characters, but it does not have a font that contains all the glyphs it needs. So that's another story. Yes, also Limlo's PSP decrypt here in the Discord channel. We are quite familiar with them. I mean, yeah, and X Delta is used to generating the patch hack tools. It's used to, unpack the image, the ISOs, some stuff. PNG Quant used to quantize the image. And of course, Paratrans. Paratrans is a platform that's quite similar to crowding, but it's free. It's free. Yes, I really recommend anyone who's trying to fan translate some game to try out this platform. It's completely free, and you can collaborate the editing with others. Yes, and of course PPSP, the awesome simulator, PSP Dev, the community, Zero Voice PSP, and also all the volunteers who contributed to the translation and proofreading, and of course all the audience that are still listening here. Thanks everyone. Thanks all of you. Yeah. When this video is played, it's probably like 2 a.m. here in China, and well, I think I will try to be here and answer some questions if I'm still awake. All right. Thank you. Thanks all of you. Thank you again.
All right, that was a fantastic presentation by Main Void. I did see that he was in the Discord earlier. I'm not sure if he's still up, but if so, he might be in the chat and he might have answers to any questions that come up. The next talk will be about Adrenaline version 8.0 by Satoru or Greyjack.
Hey everyone. Hey everyone, I'm great.
All right, and without further ado.
Hey everyone, I'm Greyjack, and I'll be presenting exploring the new Adrenaline V8. But first things first, what is Adrenaline? The Adrenaline project turns the PS Vita native PSP emulator into a highly featured virtual PSP running a custom PSP firmware. With some extra Vita side integration
Interesting. We got some weird artifacting there. Give me like 1 moment to try and fix that.
Everyone,
All right, sorry for that. And this should probably work now. Although OBS doesn't like me. All right, there we go.
Hey everyone, I'm GreyJack, and I'll be presenting exploring the new Adrenaline V8. But first things first, what is Adrenaline? The Adrenaline project turns the PS Vita native PSP emulator into a highly featured virtual PSP running a custom PSP firmware, with some extra Vita side integrations and features. Adrenaline also comes with a default custom firmware that is now called epinephrine. In previous versions, it had no official name, or sometimes even called also Adrenaline, but since this version we start to support booting to other custom firmwares, it made sense to start to differentiate the Adrenaline the app and the custom firmware now called epinephrine. But why a Vita Homebrew on a PSP conference? The Vita native PSP emulator is very minimal. The Vita only contains the Alerex CPU and the PSP GPU in hardware, while the rest is fully emulated. This emulation happens through communication between the Kermit, the Vita CPU, and Alerex, the PSP CPU. But besides those technicalities, how the PSP emulator works after the boot process starts is basically the same as the PSP, but with some quirks. This is achieved by using Taihen, the Vita custom firmware framework, and because of that we can inject custom code into the PSP emulator IPL. This allows us to run unsigned code at boot time. It also allows us to create custom Kermit Alerex commands, and also do flash driver memory card redirection, allowing us to load other modules not included in the PSPMU flash. Well, what's new on the Adrenaline V8? At this point, let's focus on the Vita side changes real quick. It will not be the focus since this is a PSP conference, but we have new graphical filters. They are very good for very retro games like PS1 era games or before, and some games with simpler graphics, usually 2D, things like that. We also have PS1 per title image overlay, and this feature is really cool. It could be used to create a static overlay for PS1 games, and you can also use that to fill the black and news space with some image or something you like. We have now the option to hide the Adrenaline menu while testing some graphic related settings. When you open Adrenaline menu, the PSP game will be paused. And also a very cool feature, we can now select a base location for the system storage drive, like the PSP Go, but you can choose the location on the PS Vita side, or even disable it and not use this feature if you don't like it. And now let's go to what's new on Epinephrine V8, the actual custom firmware. I separate the topics into 3 major categories, but it won't include all the changes that was made because it was too much for a short presentation. But it will be included. All the changes are included in the changelog that is made available in the documentation site. We have some infrastructure changes, some developer experience changes and end-user experience changes. Let's start with the pentazaming module. This is a new custom firmware system module that handles everything necessary to achieve the virtual PSP environment, from handling custom commands to exposing to the custom firmware the features from the Vita side. And it also all started as ARC compatibility layer to be able to launch ARC Core into Adrenaline. But since then, we together with the ARC team started to import this module into the Adrenaline repository and update with the recent changes made in Adrenaline, and use this new module as a foundation for the custom firmware inside the PS Vita for both epinephrine and ARC, and potentially for new custom firmwares if they ever came to be. Another new thing is that Adrenaline V8 is built using the PSP custom firmware SDK. That is a SDK made in collaboration with ARC as well, to create this collection of custom firmware library stubs, the agreed API headers, and also a collection of static libraries that facilitate custom firmware and custom firmware powered homebrew development. This project is part of PSP Dev organization, and it already came installed by default in the recent PSP Dev toolchain releases. Another infrastructure change we had was the Node DRM engine. We made improvements into the engine by using the knowledge left by Quick that reverse engineered the DRM for the PSP and the PSP emulator. And now, because of that, now we are able to launch unsigned PPP titles, both the base app as well as update. We also are able to load unsigned DLC, often used in game mods and DLC mods. And also we are able to import own PSP themes from the PSP without requiring system activations. We also had ISO drivers improvements. For example, we imported the Inferno V2 changes from ARC 4 and 5. We imported the March 33 ISO driver source code, as well as the minimal edition custom firmware ISO driver. And we created a new Galaxy controller module as well, instead of using the binaries. And together with importing the codes, we also made some improvements in there. We start to share the code related to the ISO and compressed ISO reading. We added the UMD read and seek speed delay emulations. Added support to all compressed ISO formats like CSO V2, JSO, ZSO, and even DAX formats. And with those changes, we also made the read speed of the ISO faster in general, and added the correct implementation to emulate an empty UMD driver. Another exciting feature that was added was the ability to load user-level plugins and extra RAM partition. When this extra RAM is not merged with the user RAM, when running a game, the user-level plugins will be loaded to the extra RAM partition, and that means that the plugins will no longer use the game RAM partition, which can improve the game's crashing because the plugin took too much RAM from it, and also be able to load a bigger amount of user-level plugins, because loading the extra RAM partition, we have around 16 megabytes of space entirely to use for that. If we have Inferno Cache turned off, if Inferno Cache is with the default size, we will still have around 15 megabytes of free space to use. And if the Inferno Cache is maximized to use to the maximum level allowed, we still have around 88 megabytes of space to use exclusively for user-level plugins, and that's the same size as the kernel partition, but it's all available for us to use, so we can load much more plugins and allow the plugins to use more memory as well. And that helps us to improve the overall stability for the PSP games and homebrews while using plugins. Now, for developers, we had changes into the custom firmware libraries, but it was not a breaking change. Actually, all classic custom firmware libraries were expanded to have a better compatibility with the the now maintained custom firmware API, and also reach API unity with Arc. For example, system control for user now has 100% API compatibility with other custom firmwares, and also total parity with Arc. While system control has almost complete compatibility with other custom firmware and parity with Arc, but we are missing around 5 functions that thankfully is not really used by any homebrew. They are functions that were exposed publicly by March 33 and not really, but used only internally for the March 33. And as far as I know, there's no real homebrew using those APIs, but we would like to make it complete as well. Now, the kernel user bridge also reached 100% API compatibility with other custom firmwares and total parity with Arc, while VShell control library is almost complete as well. And together with that, we had the unification of the custom firmware API used by epinephrine and Arc. So we can use the custom firmware SDK for both of our projects. With this new version, we also have 2 new libraries. The first one is the CLib for user library. This is a new custom firmware library that provides the basic libc functions that can be used by plugins and homebrews to reduce their binary size by now linking to the new libc that is provided by default by the PSP SDK. And the only downside of this library is that the functions are exported as syscall, and that means that each call to the basic libc functions does a syscall instead of a direct call, which is slightly slower. The other library is the GU-glue library. It is a VShell library, which means it's only available on the VShell or XMB, and that this new library allows the VShell plugins to access GPU acceleration when producing graphics on the XMB, which brings a new realm of possibilities for VShell plugins. This new version of epinephrine already uses this API to produce the new VShell menu that is rendered on the GPU instead of the CPU. Now for the more end-user changes, we had a complete rework of the plugin system. It used only one file to configure the plugins, using the same format as the Arc5, and both use a slightly expanded version from the Arc4. And this new configuration format consists of lines, each line configuring the plugin, its run level context, and if they are enabled or disabled. It follows the syntax: the run level, comma, the plugin path, comma again, and the switch state if it's on, off, enable, disable. Here are some examples that you can see play. The possible run levels are these ones. We have the VShell run level, the UMD run level, that is basically PSP games, only PSP games. Homebrews will not, plugins for on homebrews will not be enabled if that's with these run level keywords. We have the POPs run level, that is for PS1 games. We have the homebrew run level, that is specifically for homebrew, with the tricky part being that if a homebrew is signed, it works basically as the same as UMD run level. So if homebrew is signed, this run level, this specific homebrew will not be handled by the homebrew run level. We have the app game run level, that is basically a union of the UMD and homebrew run levels. We have a possibility to always set the plugin on or off. And we have some special handlings. That is the title ID, which allows to specify a specific title ID to enable or disable the plugin on this specified title ID. We also have the path that allows to specify a specific binary path to enable or disable a plugin. And we have also the custom firmware handler, that since we use the same file as Arc for the configuration, we can actually share the configuration files. But if you need for a plugin to be enabled or disabled on specific custom firmware, you can use this handler to specify that and have only one configuration file and not having to deal with changing the files, creating backups, one for Arc, one for epinephrine. So you can just simply use this custom handler for the custom. Another thing is worth mentioning is that the plugin path can be either a full path or a relative path. The full path is what we always have been using, even on the old configuration formats. And it's with what everyone already knows how to use. But the relative path assumes I start on the cplugins folder, which means you can remove if it is already on MS0 cplugins folder. You can simply remove that, like in this example. We also have a new GPU render VShell menu, like mentioned before, and this new VShell menu has the same options as the classic VShell menu, plus a new one. it is the advanced game options, which allows an easier way to change the options for specific for testing different behaviors when the default is not working for games. But one user can tweak the behavior and see if it's better or worse for them. And we also recommend to open a issue if we find a better option for a specific game. For example, it's not working with the default, and you found a configuration that works for this game. If you open the issue, we'll make sure to have a specific handler for this game using the configuration you found. Another thing we have is that we have the custom firmware settings directly on the XMB, and that includes a plugin manager that allows to enable, disable, or remove the plugins that you already have set. But currently we have no plugin installer, but it is planned for the future. But for now, you have to add manually in the configuration file. Another thing we have is the epinephrine custom firmware settings that allows you to change pretty much all the custom firmware settings directly on the XMB. We have also messages saying if certain settings require restarting the visual to take effect. And we also add a triangle to mark the settings that are part of the advanced settings. And these advanced settings, they are tricky to change from the default, since they can also, the same way they can fix some games, they can break other games. So use with care, and mostly for to tweak, find a better option for a specific game you want to play. But remember to put those settings back to the default when playing on other games that are known to be working correctly on epinephrine. We also have XMB system storage. The epinephrine integrates with the system storage location feature of the Adrenaline to show the system storage drive directly on the XMB. And it's basically the same as the PSP Go. You can access it for photos, music, video, and mainly games, but it has some limitations. The current limitations is that we are currently unable to launch PS1 titles from the system storage. Another visual issue is that the index MB is not showing the system storage free space, and sometimes it shows the wrong space. The save data utility for the system storage doesn't work on the XMB, but that it's not a big issue because the save data of the titles launched on the system storage is actually saving the memory card, not the system storage. So it's a lesser issue. Also, the XMB context menu doesn't open on the system storage items. But most of those issues is related for us not having enough information about the visual. More work needs to be done on reverse engineering visual, but it was enough to actually make this part work. Now we have a fix that is excited for audio files. We fixed SenseMe. For the longest time, SenseMe was not able to be launched on epinephrine, but that was fixed. And we also have a special handler for SenseMe that will cause the music to not stop when the system locks up by timer. But the inner issue that caused the SenseMe to not boot was deeper than that. The actual issue was that the model privilege level was resetted on official apps, and on Homebrews it was never set to the correct user privilege level. So we actually the fix for SenseMe also fixed for other apps. All official apps was failing to open, that was fixed, like SenseMe, Comics, etc. And also Homebrew software was not able to call the load module function when they should. And with this fix, the Homebrew software now returns to be able to launch the kernel load module functions when the user privilege allows it. So that's it, everyone. Thanks for your attention. Of course, this is just a little part of all the changes. You can access the full changelog on the docs that we have linked here. And if you have any questions or something to talk about related to epinephrine, you can call me. You can ping me on the PSP Homebrew Discord server. We are there to talk to you. Thanks so much.
Wow, that was an amazing talk by Satoru or Greyjack for Adrenaline on the Vita. Well, and the custom homebrew. There seems to be a lot of new features for the CFW. The next presentation will be about preserving Hilton team play through reverse engineering by Lucid One and Limblo.
Hello.
And without further ado.
Hello and welcome to Preserving Hilton Ultimate Team Play with Reverse Engineering and Brute Force, presented by Limblo and Lucid One. I am Lucid One and I'll be covering the first part of this presentation. Limblo and I have been working together on this project for about 5 years, so we're condensing a lot of information into a very brief presentation segment. So we're quickly going to go through an introduction and then talk about the research and all the work that had to be done to recover this patch. We'll go through the patch recovery process itself, and then we'll wrap it up with where to go for more information. But I want to start with, what the heck is this thing anyway? Hilton Ultimate Team Play was a first-person employee training game produced for the Hilton hotel chain in 2009. It wasn't a secret, it was just never available to the public. There was an article about it in a PlayStation magazine, there was some news coverage, and a hotel exec even presented on the development process at GDC. But there were only 500 copies of this thing produced, and since it was never made available to the public, once the program shut down, most of the copies are presumed lost or destroyed. So it fell into obscurity until a YouTuber found the disc at a pawn shop and then made a video about how he had to go borrow a PSP from a hotel to get the thing to run. Now, from this early coverage, we learned that you needed the game disc, you needed a special memory stick, and you needed the actual console from the hotel. So our story really begins in 2019 when a copy of this game and the memory stick appeared on archive.org. But it fails to run as is, and the people who did this archive did some reverse engineering and came up with a set of patches that were required to get the thing to run on a regular PSP. So the real question is, why? Now, the people who did the original archive hypothesized that either you needed a special PSP, there was something custom about it, or it had some certificates embedded that would allow the game to run. It turns out neither of these is the case. The game simply requires a day zero patch. But there's a fallback version of the game on the disk, the GamePRX, the actual runtime engine. And it turns out you can get that version to run if you put all of the game's assets into a single data.pack file. Now, this version of the engine was intended for developers. It's what they used to finish developing the game before they shipped it. But this data.pack file, this intact one, was missing. It wasn't in the archive because it never went out to hotels. We were able to reconstruct it and get the game to run in this mode, but this isn't the way the end users would have run the game. They would have run the patched version with the files that were on the memory stick that we had from the archive. So the other way to run it is with the day zero patch installed. This is intended for the end users. This is what they ship to the hotel. The problem was this version of the patch is encrypted. And as we learned from the archive.org copy, you couldn't simply copy it to another PSP and execute it. So this brings the next mystery. Why? So our project goals became recover the plain text patch, install the patch on a new PSP, compare the patched version of the game to the default game module from the UMD and see what the differences were, and then run this patch game as intended on original firmware. And this would allow us to fully preserve the game as it was delivered to the end users at the hotel.
Hey everyone, this is Limblo, and I'm going to talk about the research and technical part of this presentation. So what the hell is this patch? Well, it's a special executable whose encryption is twofold. First, there is the protected game data layer. Once decrypted, it reveals the second layer, the actual PSP executable data. SOCOM and Killzone are the two other games that we know of that also use this patch mechanism. The game provides a secure install ID key as part of the encryption-decryption process. This patch is installed from a DRM install package, which is a eboot.pbp archive, and the package itself is installed through the install utility API. Of course, each layer is individually encrypted and signed. Here you can see the PGD header of the encrypted Hilton patch. The PGD layer is a protection layer that can be used for any type of data. The psheet kernel module is responsible for extracting files from a DRM install package and converting them to per console PGD files. These PGDs are encrypted and signed per console with the bbcipher Mac kernel API, which is handled inside the AMCTRL module. As expected, the decrypted PGD reveals the last layer, the encrypted PSP module. The PSP header is well known as it holds all the encrypted PSP executables. It has different internal types from 0 to 10, which indicate how it is encrypted. Here, type 3 is the per console DRM type, and it is always signed by Kirk command 2. This command does two things. First, it verifies and decrypts the authored input data. And 2, it encrypts and signs per console the output data. Therefore, a Type 3 PSP module is always tied to the device that first installed it. Then, what's a DRM install package? It's a special eboot.pbp archive created through Sony's PSP developer network. Developers send their plain PRX or their data files and secure install ID. The private authoring tool then creates and signs their Type 3 PSP module that Kirk command 2 will verify. Every file entry is stored encrypted using static keys found inside psheet. Then the game can install the resulting package.
So with what we know, how can we achieve our goals? Well, it's easy. Let's have the game install this package and then we'll just play it, right? No. The installer package is deleted during its installation, and so the original installer is completely lost to time. And we can't forge it because there's still a Kirk2 key missing, even with all of the reverse engineering that's happened over the years. So what else can we do? Well, we can use a cheat patch to run the game. It's not what we want, but it does work. Or we could ask the Hilton collectors to help us. They own the original PSP, the memory stick, and the UMD. So that sounds good. So we created a decryption tool and went looking for someone who had the whole working set to help us recover the patch. They would have to use their PSP to decrypt it using our tool. Simple, right? Well, it turns out this strategy did not work out. There are very few working copies of these in the wild, with the UMD, the memory stick, and the PSP, and it turns out that collectors are not all that interested in content preservation. They're much more interested in preserving the uniqueness of their collection. So most of them outright ghosted us. One did ultimately refuse to help for professional reasons, which I sort of understand, but it was unfortunate. It forced us to take the long way. There was one more crazy idea. Maybe we could decrypt the public dump of the encrypted patch. But We had no access to the original PSP that installed it. We had no idea who had done this original archive. We had no information about the PSP itself, and so it used an unknown per console AES key, and the key algorithm was unknown at the time. So it looked like we'd reached a dead end.
Or so we thought. In 2024, a guy dumped the Kirk engine ROM from a PS Vita. The PSP community fully reverse engineered the firmware. That gave us the per console key derivation algorithm, which then gave us the Kirk Command 5 AES key. Question is, can we now try to brute force the only known encrypted patch of Hilton Garden? What do we know? The per console keys are derived from the hardware fuse ID. Each PSP has a unique fuse ID ranging from 6 to 7 bytes, seemingly random. Then what do we need? We need the exact fuse ID of the PSP that first encrypted the patch. We also need a fast and reliable way to verify a fuse ID is actually the right one. And of course, we need the brute force tool to test every fuse ID and a tool to decrypt and rebuild the patch using any fuse ID.
This brings us to the Fuse ID survey. The Fuse ID is a 64-bit unique identifier burned into every console, and it's unique, but were they truly random? We asked the community to share PSP ident screenshots, and we built a database of Fuse IDs to find out. And the results were no, it's not random like a GUID. Many of the bits weren't even used, and some of them were somewhat sequential. Each motherboard happened to fall within a specific range of Fuse ID values. So this helped us narrow the scope for what we needed to do to recover this file.
From there, what's the fastest way to verify a fuse ID is in fact the right one to decrypt the encrypted patch? Well, it turns out there is an interesting member in the PGD header, the file path MAC. Reverse engineering of the P-sheet module shows us a few things. First, the BBMAC tag is computed very early during the PGD creation, which is a good thing because we can then do tests very early. And the second thing is it is always per console, meaning it uses the fuse ID to compute it. So that's great. We can compute a file path MAC with a fuse and simply compare it with the original one. If they match, then we have the right fuse ID and we can proceed to decrypt the patch. However, can we speed up the process? We can. We need to do as few operations as possible and compute only what's strictly needed. We can use hardware AES to speed up the process even more. We will reduce the ranges of fuse IDs to test, which we already did using the fuse ID survey data, thanks to Lucid One and every person who contributed to that. Also, we have each CPU core test a sub-range of the current range. So that means we can test multiple ranges in parallel. Each thread has its own local data that is CPU cache friendly. So let's run the tool. And there you go, success. We actually tested 61 billion fuses in just about 1 hour and 15 minutes. That is about 75 nanoseconds per fuse. And it's worth saying that this was done with a 10 years old laptop. And here you can see the actual fuse ID of the encrypted Hilton patch. So we made a simple tool to decrypt the patch, specify a new fuse ID, and then rebuild the patch. That tool will be released in the following week, so stay tuned.
So, with the Kirk algorithms understood, and a cool tool that Lindblow wrote to rekey the patch to a new Fuse ID, I was able to take his tool and install that patch on one of my consoles. And eventually, I was able to test it with the actual game disk. So, does it run on original firmware? Success. We got this thing working. It is perfect, just as it would have run if you were, some kid trying to learn how to be a good Hilton employee back in 2009. So, where do we go from here? Hopefully more tools get developed in the future, but in the meantime, we have my GitHub, where I've documented the preservation work and all of the tools that we've recovered and achieved, as well as the Fuse ID survey, which you can find in a link in this presentation. And if you want to do some more research on Fuse IDs or their internal structure, or maybe find a different application for this data set, have at it. It's all out there. So special thanks to whoever dumped the original copy on archive.org, because without that copy, we never would have gone down this path. And really, whoever dumped the Kirk ROM, that's what really made this entire thing possible. Everyone involved in reverse engineering that ROM really set the groundwork that enabled us to achieve our goals. And all of the people who in the community who shared their PSP ident screenshots that allowed us to build the database of Fuse IDs, everyone who participated in that survey, we owe you a huge thank you, because without narrowing that data set, I don't think we would have attempted the brute force. And thanks also to the PSP Homebrew developer community for giving us the opportunity to share our project. Thanks, everyone. Thanks for listening. You can reach out to us at Discord. Bye for now.
That was a great talk by Lucid and Lindblow. They are also in the chat, so if you want to ask them any questions, you can go right ahead. For our next presentation, we'll be presenting Nimbus and Lighthouse, and this will be presented by Huberty. And it's actually like two different projects put together, and there's also a teaser at the end for another upcoming thing. And without further ado, here we go.
What's up, guys? This is Fuzzy Logic. Some of you may know me as QBERTY or XF or Diff from back in the early days, like the TIFF exploit days. And it's been a while, but finally came back and been working on a couple of projects with my newly acquired 1K. This year, I released Sidecar, or I re-released it, but updated for like the latest arc. And it's been pretty interesting as a project. I also released Dratini FS, which is basically a file system replacement. That might come up a little bit later, but we'll get into that. It kind of led me to working on cloud saves, really, because I didn't see any kind of plugin. I couldn't believe that there's no plugin to actually support cloud save syncing with the PSP, with your save data. So I started to work on that. It kind of led me into another project, a side project, which happened to integrate well with Nimbus, which I'll show you first. But Lighthouse is the project that I'm calling it, the name of the project, which is basically an XMB replacement. It's more like a shell replacement for the XMB to replace and modernize pretty much as many functions as I possibly can while still keeping the vanilla feel of roaming around in the XMB, using the functions, trying to fine tune the biases, especially from a functional level. So we'll see how that works. I've integrated Quick.js. I know everybody's thinking, what, you know what? For theming, it's actually really, really good using a web framework. I chose to use Svelte as it's one of my favorite frameworks actually to use in modern web, like full stack. I use it in my job. I use it for hobby projects. So I'll start to show some of that right now actually, so we can get straight to it. The first thing I'm going to show is Nimbus Cloud, which is the cloud website for cloud sync saving, which is Nimbus, the plugin. Oh, before we continue, sorry about the camera. It's the autofocus is clearly not working, so bear with me on that. Also, this whole video is going to be mostly demonstration, but I also want to show the actual concept and the code of how it works. So I don't want to get too heavy into it, but I'll try to show as much as I can in terms of what's usable and what actually integrates with the whole system. So again, I would like to demonstrate as much as possible. So let's check that out. Okay, let's quickly go over what Nimbus actually is. It's a plugin for the PSP and also the Miu Mini, any Onion OS device. Basically, it's a sister plugin that functions almost identically, but essentially it's a plugin for the PSP that allows you to back up your save data, especially all data that's in the save data folder on your PSP, minus, if you're using ARC, minus the ARC folder. But it allows you to back them all up and sync them with any cloud service. Now, right now, the currently 2 supported cloud services are Google Drive, since that hit the top of the poll when I polled it in the community. And the second one is Nimbus Cloud, which is a service that I'm providing. It's basically a niche service that has a couple of extra features that are a lot easier, that makes it easier to deal with save data, especially on older consoles. So let's take a look at that right now. So Nimbus Cloud, which is a website that you can go to, you can log in with your Discord. Currently, right now, it's set up for Discord. It allows just standard stuff, just takes your username and email. I don't collect any kind of serious user data. I just need it for basic usage to log in. You know what? You can add any amount of devices that you want. Let me remove this actually. And where's PSP? Let me put that on screen. Okay. There you go. Sorry, there's no script. I'm just riffing it. So let's just sync this right now. Okay. So the way that it works is the Nimbus plugin runs on your PSP in the background, and while you're in the XMB, in this case, I'm running Lighthouse, so you'll see I have a separate UI for it, but I can demonstrate the XMB later. But when you run the sync uses SSL, and it contacts Nimbus Cloud. Nimbus Cloud will exchange information directly and basically sync all of your data. Now, it's block leveled, so it's easier to be able to track which types of save data are coming from which devices, so you can have multiple multiple PSPs with multiple save data of the same type. Now, one of the major features that isn't supported on Google Drive, which is a supported cloud service, for Nimbus Cloud, I was able to allow the option to have versioned saves. Now, that's one of the reasons to use Nimbus itself. Again, this is a niche service, so this is going to be provided to the community for free, with like a base level amount of storage that you can use. You know, again, save data doesn't actually use that much storage if we don't include data installs and all that. But essentially, it allows you to use file versioning of any type of save data. So you can imagine you have one save file, or some games only support up to a certain amount, like 1 to 5. And in one of those profiles, you change something, or you do something and you want to go back or something like that. You've already saved that data on your PSP, and it overwrote your old profile. So in a case like that, with Nimbus, you can, if you've already synced it, you can already have both versions that are available for that particular profile, or that particular save profile that you've had for that game. And you'll just easily be able to restore them by just clicking the restore button. What that does is it swaps your newer version with an older version, or a V2 or something like that. And it would tell the PSP that, hey, this is actually the latest version, which is actually your older one, and it will sync that to your PSP. And if you save on top of that one, then it'll learn, and it'll know that that's the new one that you'll need to sync back when you're ready to do another sync. One of the challenges that I ran into really was when I first was doing this was the time zone stuff. Time is a major thing, honestly, because everybody's clock on their PSP runs differently. You know, everybody has a different clock, and sometimes your clock doesn't even work. You know, you boot up your PSP, and you got to reset the time. And so I had to figure out a way to make this work, data saves work, without being able to know the time. So one of the ways, again, my specialty is caching. So I love caches. I love putting caches everywhere I can. You'll see a whole bunch of caches here. There's caches for images. But in this case, for cloud saves, I was able to use and generate timestamps for each piece of save data, especially at the block level. Generate timestamps for the delta on each save data that is synced to the cloud, so that the cloud keeps a copy of the delta of those timestamps, and your local device actually keeps just the timestamps, and they're generated at the time of doing the sync. So it really doesn't matter what the local time of your device is. The save data will save perfectly fine, and even if your time resets and you save a new piece of data on that profile, when you sync it, it will sync perfectly fine. And that's the idea, right? The whole idea here is just to try to make it as effortless as possible to do cloud saves without having to think about it. Honestly, the idea is to just not come back here. You don't even want to come back to the site because, again, you set it up already on your devices and you just want it to sync. You want the backup to be there and you just want it synced. So that's Nimbus. Nimbus can pull some other extra data with the plugin, so it just can detect different types of PSPs and stuff like that. The way that I was going to do it, originally, was just encrypt everything. But in transit, you kind of can't do that. It depends. So everything right now, currently, by default, when you create an account on Nimbus Cloud and use the Nimbus plugin, everything is encrypted. So encryption does increase the amount of data that needs to be transferred, and we all know the PSP kind of struggles, to be honest. It does struggle a little bit with transmitting data, especially if you're using the WPA2 plugin or using Arc, which has that plugin built in. The Wi-Fi module is just, it's a little bit iffy sometimes. So the plugin itself has a lot of retry mechanisms, and I try to incorporate a lot of integrity, especially to the save file level. So that usually should prevent corrupt saves. But again, this is a beta, and that's exactly why I'm looking for more beta testers. Again, I'll put some more information about at the end. But yeah, so that's basically using the default Nimbus Cloud site. Now let's look at the Google Drive syncing, because again, this took a little bit of doing, because again, it's not just pop your API key in and just let it go. You don't want it to be expensive. You want it to use some readily available things in your account. So let's let's look at that. Now, when enabling Google Drive in the config files for Nimbus or Lighthouse, you'll basically be greeted with a new option in the syncing section, which is link Google Drive. Now, this is the easiest. This is easily done with Lighthouse because Lighthouse can display things on screen. I'll get more into that later, but you'll have a new option called link Google Drive, and the way that it works is I'm utilizing one of the OAuth consent screens that is available technically for TVs. Again, TVs back in the day used to be really, really dumb. They couldn't do OAuth the same way, especially securely. So Google actually has a built-in way to utilize OAuth on older, less capable devices, I guess you could say. Not saying the PSP is less capable, but in this case, you can see right here that we're going to use the older style version of adding a device, especially linking your device to your account. So I'm going to do that right here. Be careful with your eyes. This is going to be bright. Sorry. This is the standard Google device page. You can see right here on the screen, Lighthouse is going to show you basically what link to go to, google.com/device, and it'll give you a code. Now, this code, you go to that website, which is google.com/device, and then you enter that code in. So I'm going to enter that code in right now, and then you're going to see it link your PSP directly to your Google account. Now, when you're logging in, you'll see that it'll say Lighthouse, and you can even look at what it actually accesses by just clicking the little button blurb, and it'll say exactly what it's trying to do. It only has access to the files in the folder that is specified in the configuration, and it can only upload and delete files and download files directly from that folder. So it's scoped to the folder that is provided in the configuration. So it can't access anything outside of that. So I'm just going to connect it right now, and it is connected. And you can see right here on the PSP, it gets linked, and then you can see it linked. So to test that, again, I'm going to do this live. Let's just sync it. And the way that I scope the plugin is per device. So there is a configuration file that you can just set up. You can name your different devices if you will have multiple devices using the same linking. You can set them to have different IDs, and different IDs will allow different folders that you'll see directly in your account. And the folder structure is basically just like your save data folder structure on your SD card. You can just see right now it's just syncing pretty much everything as is from your device. It does support, I am forcing encryption for profile data, so the actual save data. The images are not encrypted. Again, they're readily available for any save file that you download on the internet for that game or whatever. So there really is no reason to encrypt them, but there is an option to, if that's necessary, if you find it necessary, or if you really want to keep everything fully secure. But you can see that they are full. And again, for the Google Drive sync, this is just a basic backup and restore, or rather backup and sync. So every time you run the sync on your device, it will back up everything that doesn't exist on Google Drive, because it uses Google Drive's folder listing and file listing. So it's not slow, but it does provide a slight lag in terms of what Google Drive can provide at the time of syncing and how much data is required. So if you have a lot of saves, again, it can take a couple seconds to actually get that file list so that the PSP plugin itself can do a diff on pretty much all of the files that you have. Again, I'm saving the timestamp of each one, so it doesn't actually have to dig and scan your whole save data folder. It just needs to check the cached file. Again, I love caches, so that's basically what that is. So again, this makes it very effortless to set up and effortless to use once you're syncing things. You can see an option here, it's sync on boot, where you can, as soon as you boot into Lighthouse, you could just have it sync. Same thing goes for the vanilla plugin that runs in just the bare XMB. If you don't want to use Lighthouse, you can totally use Nimbus as a separate plugin that you just toss into your plugins folder while XMB is running, and it will just sync on boot, and you get the same experience here. So that is the Google Drive syncing. So that's basically the basics of what Nimbus is and how Nimbus works. It's just save data cloud syncing, and I'm going to offer it, the Nimbus cloud site. I'm going to offer it and its features for free for the community. Whoever wants to sign up will be able to sign up after the beta period. So during the beta period, anybody who wants to test this plugin or test Lighthouse as well, they need to join my Discord. My Discord server is discord.gg/fuzzylogic. Just type this in, it'll take you to the Discord server. Just ask me that you want to be testing the Lighthouse beta, or if you want to test Nimbus just raw in your XMB. Currently right now, it's tested to work with Arc 4 and Arc 5. A couple of the future features that I'm trying to get to work with it is, it's obviously a lot harder, but I want to inject into the save data plugin firmware file and be able to hook it so that anytime you save within the game will trigger the save data hook, and then it'll just call Nimbus, and then Nimbus could just sync the one file so that you don't have to do a delta check and then sync whatever's available or whatever's not synced. So that is Nimbus. Let's move on to the bigger project, actually, which is Lighthouse. Okay, before we go to that, let me just really quickly show off the plugin for the Miu Mini. I was working on this in Rust, and I wanted to, get my Rust chops up a little bit, instead of just doing C all the time. Let's look at adding an Onion OS device. So we can use this. Oh, another thing to note is, yes, the encryption key in this case is account-wide. So you have one encryption key that is for your whole account that encrypts all of your save data. And then you have a cloud key per device, which further anonymizes, or rather uniquely identifies that exact device. It anonymizes it in another way. But yeah, let's see. Can you see this? This is just a standard Miu Mini. This is the Miu Mini Plus. Yeah, so there's just a basic thing that says Nimbus Sync. I know my focus is pretty terrible, but you can see right here it's already loading up. Since I've been testing on a 1K, 1Ks don't have save states, but the Miu Mini does. And so I was able to add support for save state file versioning and save state block level device. So the way that it works is you sync your one save state, and even if you overwrite that save state slot, it will register it as a separate slot, and you will be able to restore that slot over that other slot. Again, just like file versioning works for save data, except this one is more integrated because I can pull direct data from the save state itself, and you get a little bit more information, a little bit more data. By the way, also with the Nimbus site, each save data profile or folder or piece of data or save state can be downloaded individually or per game. So all you got to do, if there's a whole bunch of save states or a whole bunch of saves for a particular game, just hover over here, download, you get a full zipped file of all of the actual save files that are stored. In terms of privacy, there is features here that you can just download everything if you would like, as long as you have the key, which here is shown here. It's not stored. Your encryption key is not stored on the server in any way. The encryption key is stored here and is displayed here locally in your browser. So if I were to clear cache, clear cookies, this would be gone, and you would have to re-enter your saved encryption key, which is this exact key. You would have to re-enter that key again, in order to be able to see your saved data, or be able to restore it or download it or have any kind of use out of that data. So again, yeah, this is not stored on the server. This is fully end-to-end encrypted, which means it's generated by you, and it's not stored anywhere, only on the devices you own. You can download all the data. You can delete all the devices really quickly here, or you can just remove your whole account. And again, I'm not leaving any traces or marks, again, because this is a niche website that I'm offering for free. It takes up storage. If you want to delete your account, delete your account. It's all good. If someone wants more storage, like if you have an insane amount of snapshots and maybe you want to save game data as well, contact me if you're in the beta. Maybe we could work something out. I don't plan for this to be like a thing, but yeah, it's, if people will use it, then I'll keep it up to date and I'll keep it going. I'm using it personally. I use it for a couple of my devices, so it's going to, I'm always going to keep using it, because again, I couldn't believe that cloud saves weren't available for PSP up until now. But yeah, all right, let's move to Lighthouse. You know what? Let's do a giveaway, and the first person to, or the first 5 people to go to this site, riddlr.me, that's my puzzle site, and solve this already solved puzzle. First 5 people will get 1 GB for free, lifetime. Just send me the answer, and you're good to go. All right. Okay, let's do this. Actually, let's go through exactly what Lighthouse is. Lighthouse is an XMB replacement that's meant to boot up when you boot up your PSP from cold boot, and it's meant to mimic the XMB as vanilla as humanly possible. But it's also, I've integrated QuickJS, which is a JavaScript engine, and also glue code for Svelte, which is a web framework, a very popular web framework among developers. It's very easy to develop. This is one of the reasons why I chose it. It's super, super easy. You can see, actually, you can see right here, this is some of the code for the Nimbus site. Super simple stuff, nothing complicated. It's Svelte itself is basically HTML, CSS, and JS or TS, and that's it. Except it has a whole bunch of extra framework features that you can plug into and pull in and out and stuff like that. Like for Nimbus itself, I'm using the latest Svelte features like runes and remote functions and all that jazz. It's really useful, and it's really easy and fun to develop on. So I chose Svelte for the theming framework of Lighthouse, just mainly because it's so easy to develop your websites with, that it also makes it easy to develop the themes with. I can show you exactly what that means. So let's just boot it up right now. So that's a boot intro. Again, just like standard XMB, you can replace the boot intro with any intro that you want. I've hooked in the ME controller directly into the boot animation, so you can boot with videos, whatever format that's supported. I'll get into supported formats in a second, but you can use that as a boot video, or you can boot into what you just saw there, which was just something I threw together. It's just a random Lighthouse. I mean, I'm not really an artist, but you know, I mean, yeah, it's just a random animation, but that's built in Svelte to actually show that. So you can actually use the web framework to make your own intros as well. They're scoped to theme, and then there's a global one. So I tried to make this, it sounds kind of weird to basically describe it as a web framework, because again, that's how I modeled it. I modeled it after using, because I use Svelte daily, Svelte kit daily, and I tried to bring some of those concepts over to Lighthouse. And you'll see it in the code once you'll be able to make your own themes. But again, you can see right here, this is the base theme. The base theme is me spending a lot of time being obsessed with the vanilla XMB experience that was made by Sony. Nothing can top that in my mind, for that, in terms of just what they were able to create. So for me, I tried to create it as closely as humanly possible but also keeping it modernized. And there's a lot of different ways that it is modernized. I'll show you a couple of the extra functions. It's still in beta, of course, that we're still looking to see which functions from the old XMB do we really want to pull in to the new, to Lighthouse itself. So we have the Cloud Sync thing here. This is going to be changed. It's not going to be like an ugly interface. I want it to be more XMB-like with the animation style. By the way, the animations to replicate in the XMB is insane. Like, it's not just a simple SQRT. It's not just a simple tween. There's a lot of things going on to get the animation exactly like how the XMB does it. Because again, it's time-based. You would think that it's frame-based, but it's actually not. There's a whole bunch of stuff. There's a whole bunch of stuff to try and get everything to be as vanilla as humanly possible. But again, so let's go through a couple of the features that I've built into Lighthouse, just at the base level, just to get like a footing of what's going on here. So you can see there's a separate file section. So I have built in just a basic file manager, a standard file manager where you just look through the SD card or Flash-O, and you can get some basic functions like new folder, copy, cut, delete, rename, that stuff. There's also protection against accidentally writing stuff to your Flash-O or Flash One. Thanks, shout out to Yuki for testing that and giving me a really good alternative for that. So it's a relatively safe file explorer. There's no editing built in, like in terms of like text editing or anything like that, but I am looking into if people actually want that, then let me know, and maybe that's a thing. Photo viewer, standard basic photo stuff. Audio and video is kind of where I derailed from the standard that XMB supports. So the current supported formats for audio is MP3, .wave, .ogg. I managed to get FLAC working. Like, I solved the desync issues so that I've tested like really, really large FLACs. Like, we're talking like probably the highest one I tried was like a 300 megabyte FLAC. That worked fine, no desync. So that works natively here. AT3, standard A-Track 3, which is already supported by the PSP. AAC, which is like M4A files. I don't know who uses that anymore, but my main target was FLACs, waves, and MP3s, because again, those are the most common that you could see. And basically, each one of these sections or categories is themable. So the entire thing is a theme, and then each category can be themed separately. So like this music player right here, it's bog standard, not really anything fancy, just a bar with tracking, timestamp tracking. You can theme that. You can make it however you want, because again, everything you're seeing is rendered in Svelte. Everything's rendered in Svelte. There's glue code for the JS seam. There's a seam that connects the C. There is C, obviously. You can't really avoid that in this case, because again, we're trying to be performant, but also maintain some form of themability that's recognizable. So for the video category, basic stuff that we support, PMFs, obviously that's native to the ME. Anything that's H.264, MP4s natively, MOVs, M4Vs, 3GPs, only because old phones used to support that. Basically as a container, FLVs as a container, using codec ID 7, I think it was, and MKVs as a container, as long as you're using AVC and H.264. I offer in the beta, I provide some FFmpeg commands that you can use to just quickly convert any of your files directly to any of these containers, PMF, MP4, FLV, MKV. You can get the benefits of like an FLV or a 3GP or an MOV as a container. You can use those benefits as a container as long as the H.264 stream is still within that video. So again, those containers are all supported as long as those video codecs are used. So yeah, like I just threw together a whole bunch of randomly generated, not randomly generated, but I just chose a random spot in a random movie to basically see if I can get FLVs to stay in sync, because that was one of the challenges of incorporating different containers. Because again, a container's already, it has its own quirks. Video codecs, since they're all standard, you're using H.264 AVC, sorry. But in this case, we can support two different types of audio codecs, AAC and HTRAC3. So you don't actually have to do anything crazy to get that converted. And things just play natively and still in sync. The longer the video, the harder it was. But as long as you're not watching a video that's like 8+ hours, then the desync should not be a problem. That's pretty much it for the video. For video itself it's relatively simple. We're using ME. Honestly, I'll give a shout out to MSID. His write-ups and his work on ME is just chef's kiss, honestly. Like it really goes in depth to exactly how ME works, VME, ME, and it's just good stuff, honestly. If you guys get a chance to read up on it, it's a lot of stuff he did. There's actually a lot of content there, but if you read it, if you get a chance to read it up, it's actually really good stuff. It's really good stuff. Oh yeah, so the CPU clock is, I'm hooking into Arc5's function, which is to get what's available here. Arc4 does a similar thing, but it actually uses a different function name now. I think they changed it from what it was. I'm not sure the reasoning. It's probably for something, I don't know. It doesn't matter. It's changed, and I try to support both, but it really depends. So again, I need more PSPs to be able to test with. So hopefully I can get some more testers to get through that. I ported over some basic functions, standard USB function. Also I built this context menu to be pluggable. So again, with your theme, you're able to theme the context menu, get way more control over exactly what's being displayed to the user. A couple of extra features that are not normal for a standard XMB. This is another reason why I'm saying it's a little bit of, I guess you could say, modernization. We can go to here. So I have a thing called widgets. So I have system indicators and widgets. This is the going name for them currently right now. System indicators are currently anything that's up here in the header here. So any of these elements here, I would consider them an indicator of something. So I call them system indicators. Widgets are something that comes with your theme. A theme creator or author can actually create their own widgets that come with the theme itself. So I'll demonstrate that in a second. But for indicators, you can see right here, I have a couple that are built in, but I'd like to add more depending on. We have an FPS counter that you can actually move to specific spots. So there's different sets of areas. So you can have like, in the header, you can have right aligned, left aligned, stuff like that. Syncing indicator, which is also considered a system indicator, since in Lighthouse, syncing and cloud syncs are built into it. You don't actually have to use it, but it's there. You can actually move any of the indicators as long as you know where you want to move it. You just press square. Right now, currently, you can just move all of them anywhere they go. These indicators right now in the XMB are pulled directly from the firmware files. So live, so not prepackaged. So again, when you run Lighthouse for the first time, it's going to try and extract all of these icons, all of these indicators, all this stuff out of the firmware files directly, so that I don't have to, you know, bundle them in, cause licensing issues and all that jazz. It just pulls it directly out of your access to your firmware files already. There's some missing here because, again, I haven't decided on what icon to use yet for these, so you just see it's a little bit different. But let me turn on a widget. Like this one here is a wedding. Sorry, not a wedding. A weather widget. Let me restart just to show how it looks. So widgets, the way I built it was it uses a kind of like a styled framework where you can, in the metadata, you can allow the widget to access the internet. Different links, so like an endpoint. You can let it hit an endpoint, kind of like a normal stack. You can provide it params, you can provide it anything, and you can get back a result. And then that widget can display, in this case, it's the weather widget. It's showing the current weather of a particular longitude and latitude. And yeah, it can pull data and it can store data, or it can run a function for you, again, in TypeScript or JavaScript or something like that. Something that everyone already can do. It's not highly performant. It's not meant to be highly performant. It's meant to be visually appealing, or a widget can provide certain things. It doesn't actually have to live up in the header here, but I've had, in the base level, I've had it so that you can specify your widget to live up here in whatever. You can have any amount of widgets. You can have it live up here, or you can have it live in the body of the theme. So you can have it in the background here, somewhere here, make it, I don't know, you can have an idea to ping hardware info on your PC and just show your CPU, because people love doing that. So yeah, just a little bit of extra flexibility when it comes to, you know, displaying what you want. That was one of the main goals of Lighthouse itself, was how can I get it so that you can display what you want without causing too much in the heap, causing too much, you know, memory issues, overflowing stuff. I had to try and keep it controlled, but still customizable and performant. So this is kind of a good middle ground to use, something like a web framework. And Svelte is really, really fast in general. So let me show what some of the themes. I just threw together some random ones. Like I was just trying to think of some random, like different styles that you wouldn't expect like a theme to be. Like in this case, a terminal theme where everything looks like it's from a TUI or something like that, or like a deck theme where it looks kind of like, has like a weird sidebar, kind of like the Steam Deck or something like that. Another outrageous one was the grid. This one's interesting because, you know, it completely changes the whole navigation path. And this all lives in just the theme files itself. This is not in the code or in the C code of Lighthouse. So you can see right here, I guess you could show you, yeah, even in the XMB theme, you can see the way that themes are designed. They can, or you know what, I'll get to themes in a second. Hold on. Let's go through the game section, actually. You know, I really want to do that. Don't worry about these buttons. These are just, hold on. Let's switch this back and go back to this, because I want to show you the actual modernization, the stuff that I was looking at, to improve, which is game list loading. So this is in the same vein of when I created PSP Sidecar. Sidecar is a game list caching plugin, which basically takes the whole list of all your games, all detected ISOs and all that, caches them, and appropriately fits them in a binary file so that it's really, really quick to access them. So the way that this works is that it's the same idea, except the cache is live. So in your game files, you open up games, instant load. Even though you can see there's lots here, there's lots, but it was an instant load from fresh. And I'll show you raw. Let me restart it fresh. Straight in, games, instant load. Not even a second. And you'll notice here, there's another thing. So aside from the instant load of the actual list, whoops, sorry, let me restart this. Or you know what? Let me cold boot and show you a fresh. Unplug that. Let me show it to you from fresh, just so you can see a couple of the different things that I did. So there's a lot of caching done here. There's caching for the game list. There's caching for the icons, and I can show you what I did here, which is super cool. It's really cool. I could show you. You know what? Yeah. So this. So one of the technologies I used was blur hash. So you'll see in this list, you can see some of them look a little blurry before we actually get to them. They load, but right before they load, you can see that they're a little bit blurry, but then they load. Now, this is the amazing thing with blur hash. I use this all the time. It's really cool. This is what I built in here is a custom version of blur hash that's optimized for the PSP. So I took out a lot of the freaking encoding stuff. But let me show you here. Watch your eyes a little bit. This is going to be bright. It is a bright screen, but this is blur hash the site. Again, you can hook this into any website. It has a whole bunch of like SDKs and stuff like that you can hook in. But you can see right here, you take an image of any size, of any color data, and what it will do is you specify the amount of components. And when you do that, every component you specify, it will convert directly to its own, I guess you can say tokenized, but it's not really tokenized. It's more like it's a full object. It's a full object that converts directly to a blurred image. You can think of this like a skeleton image. If you're into web frameworks, the skeleton replacement would be something that you would show the user before you show the actual image. It's something like a preloader or like a lazy load for web. This is really quick to load versus the actual data of the image itself. So utilizing this and me encoding way less, because again, iconos and picos and pick ones, they're already small, you know. They're 272, you know, for this resolution on PSP it's good. It's good enough to show text at a legible amount, but it's already small, can't be compressed. And so the better thing to do, oh sorry, let me, that was my really crap camera. The better thing to do would be to blur hash it instead of caching the whole icon. Now, what that means is that you'll see some slight blur, but again, it's so fast to actually load that. The blur is actually instant. To your eyes, it's really fast to actually load, and it's really quick to actually navigate because you don't actually feel any kind of slowness or lagging. Kind of like in the native XMB, when it starts to load a little bit slowly, it starts to pull. You start to feel that drag in the navigation itself. In here, because it's showing a blur hash the entire time, you don't feel any kind of pull or lag in that sense. So it's a cool piece of tech that I thought would be a really cool addition to speeding up the list even more than Sidecar. So this is faster than Sidecar, actually. So that's another cool thing. Another caching thing that I did was I ran into a problem one time where I was looking for a game that was within a list. And now a lot of people use category games like, game categories like. That's a really good plugin. If you're not using it, please use it because it's really good. You can organize your stuff, your games in folders. With Lighthouse, I didn't want to have to deal with the plugin. I didn't want to have to actually add support for that. Instead, I just built in support. So if you create a folder in the ISO folder, it's going to create a folder here. And you're going to have that folder automatically created. You don't need a plugin. It'll just detect folders. And it goes down multiple levels. So you can do folders in folders if you wanted to. Where the second cache comes in is I created something I'm calling the AZ slide bar. Since we're not using the analog stick in XMB for anything, I decided to add a little bit of a useful function for it. You pull it down, and then you see a slide bar fade in. And again, it's cached, so it at the first load, it loads all of your games and homebrew and tools and whatever, everything that's in your SD card that's detectable in the game list. It loads it all here, and you can just move your analog stick to just quickly go over whichever one you let go, instantly loads that cache. Even if you want to surf around, you can just press X. You can go really quickly, really slowly, and just, yeah, it's really, really quick to do. And I was looking for something, again, with the theme of Lighthouse. I wanted it to be effortless. So to me, this was more of an effortless way to surf your games, get exactly to the one you want. It's not labeled by folder, but it is labeled by character. And if you know exactly what character you're looking for, you can just go there and you get only those. So that's one of the main ways. There's another cache, actually, that I made that it was trying to solve a different problem. Now, this new problem is actually interesting because say you had a set of games in a folder. Like here, I have games in a game folder, and say I wanted to get to P2. I'd have to still go into the games folder and then get to P2. Even if you had folders that were A to Z, like A to F and then F to... Even if you had that, you still had to scroll to get to the game that you wanted to. Even if you sorted by letter, you would still have to scroll and then get down all the way to what you wanted. So to solve that, I wanted a way to make it more spatial. So when you're viewing it, you're visually aware of where your game is instead of how to get to your game. It's quicker. So it's basically, I call it grid mode. Press square, and all it does is it loads all of your cache colors, blur hashes, all that jazz. It gives you tiles for each game that's in your game list. It uses another cache that can be loaded at boot time. So again, this does not take long. Every time it's fresh. And the important thing is it's deterministic. What that means is basically every time you do it, it's the same. It'll always be the same. And this helps visually because say you're looking for a game that you already know where it is. Like, you know that this game is here. Always. It's always going to be here. Every time you reload it, you know that it's going to be four rows down and whatever columns here. So again, it's meant so that you can build a mental model in your mind of where your game is so that you can actually get there a lot faster. Because again, if you're looking in a folder of folders that has a whole bunch of games in it, it's good for organization, but it's not good for navigation. It's hard. It's a little bit harder. But if you can go down a couple rows, you just skip a whole bunch. And you just go exactly, every time you go to the exact same square that you know that one game is going to be. So again, that's just another pleasant way or effortless way to get to the game that you want to play. So that's that. So that's the main benefits of using Lighthouse. I do also have a Wi-Fi or a wireless wizard, I guess you can call it. It's a wizard where you can enter in. I put in a bog standard, like a bog standard OSK. I didn't want to use the built-in PSP one. The reason why is because if you're going to build something that is themable, you want it to be, everything about it to be themable. I wanted the context menus to be themable, the buttons. I want the OSK to be themable. So you can theme this as well. And it's more of a cohesive experience when a theme author comes in and they want to make something extremely cohesive. They can have the colors down. They can have the border radiuses down. And yeah, so that's what I opted out of using Sony's built-in stuff for that. So that is about it in terms of features for the baseline Lighthouse as it currently stands. I can show you a little bit about how the themes itself work. It's basically a standard svelte file, just like how over here we have the same thing, same standard svelte that builds directly into this to the site. Super easy, component based. Same thing for your theme for for Lighthouse. We have I created some extra stuff like const for meta. We have like a little bit of extra type of metadata, kind of like I guess you can call it const for your own theme, but essentially it's a better way to metastatically give you extra options and offer it at the base level of the theme. So what that means is, like in this case, I had a theme, or sorry, I had a widget like the weather widget, and the weather widget itself requires web access. So you can see right here, it uses whatever. I just chose a random, whatever was available at the time, this endpoint that was freely available. But this endpoint, you don't know what the theme author is using. You don't know what endpoint that is. So what I did was, in the actual PSP itself, when you're switching to a theme, like say you're from a different theme and you're switching to a theme that has a widget that uses an endpoint in it, when you try to switch to it, it will inform you. It's going to give you, it's basically going to outline using this metadata, and it's going to tell the user, hey, this theme actually contacts these endpoints, how many ever endpoints are for whatever widgets or whatever. And if you're okay with that, then click yes, and then the theme will activate, and then it'll do whatever it needs to do to pull in that data for that theme. But again, I wanted it so that each theme had its own manifest that basically told the theme picker and informed the user exactly on that. So I tried to make like a templated version to try and make it easy, but I got to write the docs for it. There's no docs. I'm stalling on the docs until I flesh out like the rest of the features. But again, the widgets themselves, they're built into the theme. They use basic rudimentary HTML with added on TS or JS. Standard stuff that you don't need to know any deeper programming language than the basic web framework stuff. I tried to make it as easy as possible, pulling in whatever's glued into the JS theme and just exposing a lot of these consts. Like there's a lot here that I tried to expose. I'm going to write up a doc that fully outlines exactly everything I exposed, including functions like using like the AZ bar and all that stuff. Again, things like that, those can be themed as well. Anything that's built in, I try to make it so that it's themable, so that a theme author can create a very cohesive experience. That is pretty much it. It's a lot. I mean, it wasn't that much, honestly. A lot of the work here was mostly research. MSID, really good stuff. I wouldn't even have touched this stuff if it wasn't for MSID. Yeah, that's just, it's really cool stuff. Really cool stuff. If you can check it out, definitely check it out. It's really good. Yeah, that's pretty much it for me. Sorry, future me interjecting really quickly because I forgot to show off WebSockets, which is a new thing that I got working on Lighthouse. And let me just show that off really quickly. It's actually really cool because I'm using SpacetimeDB, which is a new infrastructure as a service, blah, blah, blah. But essentially, it allows us to use WebSockets, sub, and pub. What that means is that the actual, like we can do features like leaderboards, like a global chat, something like that, where the PSP itself has to do a handshake every time it tries to go and get something from the internet. But with subscriptions, not subscriptions in the normal sense, but in the web sense, the WebSocket sense, you can subscribe to a channel, which in this case is like a global chat, and it's extremely fast, where there doesn't need to be a whole new acknowledgement just to get a particular message through to the server. So we skip all of that, and it's extremely fast to pull in data. So it doesn't have to, like, you can see the Wi-Fi LED is still on. That means the socket is still open in this case when Lighthouse is running. And while the socket's still open, it can still fetch and receive, send and receive data without having to do another call. That just look how fast this is. I pulled a full leaderboard. It's basically like an aggregation function that runs on the server, but it still did pulling full data directly from the server extremely fast. There's also a separate function where you can use personal data. So I'm providing a separate, very minimal plugin that just runs in your games. It can just track how long you've been playing each game, and it will save it personally on device. Once it saves it on device, you have the option to, if you want to look at the global leaderboards, you could submit your times, which is how long you've been playing a particular game, how many times you launched it, how long you spent in it. You can submit that to the global leaderboard, and it'll be aggregated in a separate server function, pretty much in the background. So anyone can come in here and just look at what's the most launches for a particular game, or what's being played this month or this week. Data like this is faster to transmit when you're using pub and sub, especially with WebSockets. You can have multiple channels subscribed to, where each one of these is its own subscription, where it can, anytime this data is updated and you go in here, it doesn't require a new acknowledgement. It doesn't require a new, completely new Wi-Fi setup to just go and connect and get that. This is all live. It comes in live. Same with the chat. Chat, again, completely live. It more or less will load the most. Right now I have it set up to just 10 messages. So it'll load 10 messages, and once you hit the threshold for 10, it will then load the rest in increments of 10, just to, save on things. Because again, nothing can get around a PSP being actually slow. But yeah, that's the WebSocket interface. That's really, really cool. It can actually be used in plugins as well. So I'm looking into trying to get that going, because there could be a lot of cool stuff that can be done, because it doesn't require too much setup, and maintenance is very low when it comes to WebSockets, because again, you just keep the one thing open and you can transmit data. So yeah, that's that. I guess I could say thanks to Acid for letting me know about embedded TLS. I did not know that plugin was available. He showed me, and that allowed me to do, or to modify it so that we can get SSL built in. So that works. Yeah, it's pretty good stuff. If you would like to test the beta currently right now in its current form, it's mostly fully functional in its current form. Just visit this website, which is discord.gg/fuzzylogic. That takes you to the Discord server for my community. It's a puzzle community, because I run a puzzle website where people can go in and play puzzles and win prizes, stuff like that. I do it for fun. But I also use that server for a lot of other things, including the PSP releases. So if you want to get part of that beta, just join the Discord, and yeah, just ask me and I can let you hop in. Just give it a shot. That would be it for me. Yeah. Looking forward to feedback. And thanks for your time. Actually, before I forget, let me tease this thing from Commando, from Total Commando, the YouTube channel. He also, as I was talking to him when I was making this, he's also working on his own shell for the PSP, which is customized to how he likes it and his personal taste. And honestly, I've taken a look at it and it looks amazing. He just sent me some teaser. I'm going to tease it a little bit. I asked him, he said it's okay to take a look. Let me just take a quick look at this. This looks really good. It actually looks a little similar to my terminal theme, but it has some really cool stuff in terms of like how it's designed in terms of his design language. So I'm really looking forward to see what Commando comes up with when he's done with that. That's going to be really, really good. I can't wait. All right. Thanks.
Yeah, and thank you to QBirdie for an amazing presentation. He should be hanging out in the YouTube chat, so if you have any questions, you can ask it there. But this is the last presentation for this year's PSP Homebrew Development Conference. Thank you everyone for coming. Thank you to all of our presenters for making lovely presentations, both live and pre-recorded, and putting in the effort to show up this year, and we'll be happy to do next year. A couple other things that we'll probably be doing is this year we'll probably end up splitting up the talks and re-uploading the pre-recorded ones as well. Expect those to drop starting next week. Yeah. Thank you guys, and have a good night.